Hi there and thanks for watching. If you like the content of this video, please like and subscribe. Alright, for this course you will need Visual Studio Community and you can get it for free. There is of course an enterprise and professional version of Visual Studio, but those cost money and there's no need to spend money on this course, so by all means get the free community version. This is what it will look like. If you want to create a new project, you can go to File, New, and Project. Now, yours may not look exactly like mine, but there are a lot of different kinds of projects you can make in Visual Studio because C# is used for so many things, from making console apps to games to Blazor to APIs, that they have all these sorts of ready-made projects. What you will see in this tutorial are console apps. Okay, so I will always be making a console app. You can do that as well. So to make a console app, you just select it. If you don't see it on the list, you can just start typing it at the top and then it will show. Notice that there's a C# here. I'm not working with Visual Basic, so I'm working with just C#. So we'll say console app, hit next, and then you can name your console app whatever you want. You can select the location and the solution name. So I'm just going to go ahead and create a console app just called console app. We want .NET 6. And then once you hit create, it will handle the setup for you. So you will have what's called a solution. We look on the, there's two parts to Visual Studio that you really care about. On the left side is where you're going to actually write your code. Okay, we begin with program.cs, which is the main entry point into the program. And on the right side of the screen is basically like your file manager. Like it keeps track of what files there exist inside your project. You'll notice that there is a purple thing here, which is called a solution, and then there is a C# box called console app 1 or whatever you named your console app. So the solution is basically a container for all of the stuff related to your project, and then you have individual projects and you can have more than one. For right now we're just going to have one and we'll already be set up with it. To run your program, all you have to do is hit this green arrow up at the top. It will have the name of your app. Mine just says console app 1. Yours may say something different. If you hit the green arrow, you'll notice at the bottom there will be some text. It will pop up this terminal, and then in our case it just says hello world with some text at the bottom. All right, this is the console. Okay, that's why it is called a console app. It is meant to bring up this console, this black screen, and then show stuff on it. Now, C# is a compiled language. What that means is that before it runs, it compiles. It takes your code and turns it into ones and zeros that the computer uses to actually run the program. This also means that it can detect certain errors before you run it. So for example, let's say you fat finger right line. Okay, so console.writeLine, let's say for some reason you do it with like a lowercase l as opposed to uppercase L. Well, this is incorrect. And so what you'll see is that there'll be these red squiggly lines underneath your mistake. What this means is that your program has a compilation error, meaning that it will not be able to compile. So for example, if I tried to build this program, I would go up to build and try build solution. It will attempt to build, but notice it'll have this one error. Console does not contain a definition for write line. That basically means there's a problem. If I try to run my app, it will pop up there were build errors. Would you like to continue and run from the last successful build? So you, as a C# is a compiled language, you have to make certain that the compiler is happy before you run your program. The reason for that is that, again, it has to go through the whole program, make certain it can convert everything to zeros and ones, and then run it. This is different from languages like JavaScript, where JavaScript basically just starts on line 1 and starts running through the program until it hits an error. With C#, there are certain things that are compilation errors that basically say like, hey, you misspelled something, or you're using the wrong type, or something that C# is angry about, and C# will not let you run the program so long as there are compilation errors. Okay, a compilation error will look like this red squiggly. Okay, the red squigglies basically mean, hey, like you have a problem here, you need to fix it. Again, your program will not run until you fix it. So those red squiggly lines have to be worked out before you can do anything. So if you're experienced with languages like Java, this will seem very familiar to you. And if you're new to programming, just know that the Visual Studio is here to make certain that C# compiles, and you also can use it to run your program pretty easily. So you'll see me constantly hit the green arrow to run my program. If you ever want to test to see like, hey, is my program capable of being run, you always can go up to build and do build solution. Okay, if it if it's good, everything's right, you'll see this like build 1 succeeded. That means that it had no problem building your program. All right, that's the basics of using Visual Studio. This is the IDE we will be using for this course, and you will probably be using professionally once you get into programming. All right, so in C# you have different data types, right, variable types. And I'm going to use the word type a lot. And when I say the word type, I don't mean like typing in a keyboard. I mean like category of data, all right? So when I say the word type, I mean basically synonymous with like category or kind of, all right? So we have different pieces of data that we're going to have to store in our program. It could be people's names. It could be the like total amount of their shopping cart. It could be whether or not they're a premium member. That's just for e-commerce. There could be all sorts of things in our application because people can build applications to do all sorts of things. Position of a car on a freeway, if you're doing like a Google Maps kind of thing. If you're doing some other kind of program, it could be a completely different set of data. So because we have all this data, the data comes in different varieties. Some data is in the form of numbers, right? Like ages or shopping cart totals or XYZ position of a robot. Basically, your imagination's the limit. All right. There's other kinds of data that's not numbers, where it's like people's names or locations or things like that. Other kind of data could be whether or not someone is a premium member or whether or not someone is a manager. Okay, so they could be off-on kinds of data. Right, but all this data has to be put into the computer, and the computer has to know what kind of data it's working with. Because we're learning C#, C# is a statically typed language. What that means is when you give it a piece of data, it needs to know the kind of data it's working with. What type of data is it? It needs to know the type. All right, and when you declare a variable, you need to also tell C#, hey, this variable is of this type. So let's look at the first one, which is an integer. All right, so the way in C# that you declare variables is first you get the type, in this case int. Okay, so this part is always going to be a type, int, long, float, double, whatever it happens to be. Then you give it a name. Common beginner mistake is to think that this name has some sort of magic powers, like the computer knows what this is. It does not. This name is something we come up with entirely on our own. We could just as well call this Aardvark or Superman or Captain America. Like the variable name is just literally a label that the human being comes up with. Now you'll see in programs when we create variable names, we give them logical names like first name, last name, things like that, so that we and other programmers understand what the variable represents in the real world. But just keep in mind, the computer has absolutely no understanding at all of what the variable represents in the real world. It's just a label that we put on it, and we can just as well put another label on it as we feel like. All right, but the pattern is always going to be int. So the type of variable we're working with, what category of data are we working with? Then we're going to give it a label, and then we're going to set equal to something. So in this case, I have integers, which is for whole numbers. All right, so I have this really big number right here. Right, an integer is when we want to have a whole number, basically a number without decimals. So it's going to be there's not going to be a point something 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 afterwards. Right, it represents an integer. All right, now there's another type called long, okay, which does the same thing. It's also for integers. The difference between int and long is basically the maximum value or minimum value it can hold. So what I mean by that is, notice how I have int whole number equals this huge gigantic number, right? So it's like 483,000. So it's like 2,147,483,647. Big gigantic number. Notice how if I raise it by 1, okay, so if I go up by 1, the compiler marks this as red. Because remember, C# is a compiled language. The compiler checks to see if there's errors. If there are any errors, it will not run. So it's red. Why is this red? We hover over it. Represents a 32-bit unsigned integer. All right, so basically it's saying like, hey, did you mean like this unsigned integer? Is that what you meant to use? And the reason it's saying this is because this number is too big to be represented by an integer. So this number is the right size. Anything above this, integer cannot hold it. You can think of integers, the difference between integer and long. Integer is a smaller box than long. Integer can hold less data than long can. So long, you can have a huge, gigantic number like this, and it's perfectly fine. All right. Most people use integer in their daily life. Some people use long. For the most part, the only thing you really have to remember is that long can hold bigger numbers than integer. And again, if you also make it negative, all right, it will work in the opposite direction for negative. All right. So int and long are for whole numbers. For numbers that have a decimal after it that need like, or maybe they're like irrational numbers or numbers with a fraction, then we have float and double. All right, and again, the difference is the same. Float cannot hold as a big of a number as double can. All right, but the main thing about them is that they have numbers that are fractional. Like they have 1.123, 54.234. Anytime you have a number that has a decimal to it, you're going to need to use float or double. Notice how, let's say I did like int, this doesn't work, equals 5.45. If I try to do this, okay, it will give me a compilation error because integers have to be whole numbers. It will give you something like cannot implicitly convert. Basically what the compiler will do is like, oh, you said this was an int, but you gave me a double. I'm going to try to convert it, but I can't. Okay? What that basically means is it's like, hey, the two don't match. Notice how with float I put an F at the end. Okay, if I take this out, you'll get a compiler error again because essentially when you don't put, if you have a number with a decimal and you don't put a letter after it, it's going to assume it's a double. So we put F here to let the compiler know, hey, this is a float. All right, and then everything's hunky-dory. And again, the only difference between these two is that double can hold bigger numbers. Okay, pretty much you're going to use double most of the time anyway. People use float, long, int. I mean, you'll see in the real world, people do what they feel like doing. Stick with int and double for right now if you're just a beginner. Now, if you're wondering, well, Jonathan, what's the actual max value that I can hold with one of these, like int, long, float, or double? Well, you actually can check. There is a special property called max value. I did float.maxvalue.toString, and I'm going to run the program real quick by hitting this run button up here. It will compile, build, and then you can see that, hey, like, this is the maximum, like the maximum float value is this number, the maximum double value is this ridiculous number, the maximum integer value is this, and the maximum long value is this. And you can see that clearly, like, float is smaller than double, integer is smaller than long. That's the main thing you need to like learn. I would not memorize the maximum values. That is rarely, if ever, a thing you need to worry about, because again, if you actually go over or under, like, the compiler will let you know that you've made a mistake. So I would not memorize that. It's just a piece of trivia. Other types of data that we can encounter for example, decimals. Decimals are great for when you're like working with money, with transactions or anything financial. We indicate a number as a decimal with M because M is for decimal. D was already taken, so they just went with M. So again, if I don't put M on here, it's going to give me a compilation error, the red squigglies. So I have to put M to signify to the compiler, hey, this is a decimal. All right, and then we do 10.54. And again, my personal recommendations when you're working with transactions or money, use decimal. All right, then we have Booleans, which is like an on and off switch, true or false. Okay, there's only, two options. Okay, are they a premium member? Yes or no. Is the light switch on or off? Anything sort of 1 or 0 kind of value you can use a Boolean for. And again, we say bool, name of the Boolean equals true, and the other value could possibly be as false. Okay, either one of those works. Strings are for anything that are not numbers. That you don't do math with. The way I kind of like let people, like for beginners, the rule of thumb for like string versus like a double could be like, hey, are you going to do math with it, right? Because a string could have letters, just like we had this name Steve Rogers, but you could also put numbers in here and symbols, okay, as much as you feel like. All right, letters, numbers, and symbols, it's all good. You need to use double quotes in order to make something a string. So when we do double quotes, that indicates to the compiler, hey, this thing is going to be a string. All right, so when you see me say that we're going to make a string, and I just start putting in quotes, that's what I mean. So again, follow the same pattern. String, name of variable equals double quotes, and then inside the quotes you could put letters, numbers, or symbols, okay? Spaces, whatever you want to have in here. Some more esoteric, less used, but still good to know data types in C# are byte. Bytes come into play like a lot of times with like files. When you're like taking files and like uploading them or downloading them, although you don't really need to know much about that. We have like arrays of bytes that sometimes comes into play. A byte can hold a value between 0 and 255. All right, so if you probably put 256 in here, it's going to give you a compilation error, right? It's for value between 0 and 255. And char is for a single like letter, right? So notice I put single quotes. Okay, char is single quotes, string is double quotes. And then inside you could put a singular letter. If you try to put more than one, you will get a compilation error basically saying too many characters in character literal. Basically saying, hey, this is a char. And you said it was a char, so therefore it's got to be just one letter. That's it. All right, these are all the data types. Now to go back to the idea of C# being a statically typed language, some people say strongly typed, some people say statically typed. It basically means that once you decide a variable is of a certain type, you cannot change it. So for example, on line 22, I have string name equals Steve Rogers. I can change that to another string. I can be name equals, I don't know, Wanda Maximoff. And then I can be name equals, I don't know, Scarlet Witch, whatever, right? You can go ahead and change it from one string to another. I can't change it to an integer. I cannot do name equals 10. All right, the compiler will give me an error noted by these red squigglies. I'll hover over it. Cannot implicitly convert type int to string. What this means is name is a string, but you're telling me it's equal to an integer. Those two things don't match. Strings and integers are of different types. They cannot go together. All right, so let's make a console app, and let's ask the user for some information and print some stuff out to the console. Now, truth be told, in your career, you will not make that many console apps, especially if you're a web developer. Web developers make web pages and web apps and all that good stuff. Console apps are normally for other developers, like people who work for the company to actually use them, because console apps don't look that pretty. So you may do them, but they're really good for learning, beginning programmers. So I don't want you to think that like this is what you're going to be doing for your job. All right. C# has a bunch of built-in functionality for displaying stuff to the console and asking the user for information. So it begins with console with a capital C, and you'll see it turns green, and we're going to do dot, and we're going to do right line, and as is tradition, we're going to do hello world inside quotation marks. All right, so you got console dot right line parentheses hello world inside quotation marks. That means it is a string. Remember, quotation marks signal to C#, hey, this is a string. All right, now hover over the right line, and you'll notice that it's got, it says void console.writeLine, string value plus 17 overloads. This is what built-in C# functionality looks like. Like this method, writeLine as a method, is built in, right? We don't have to do anything. We don't have to like set it up, nothing. We get it for free right out the bat, right? Because somebody wrote code that did this. All right, and if we run our program, to run the program, come up with this green arrow, and hit it, and there we go, hello world, right? Very exciting. All right, let's ask the user for some information. All right, so for example, console.writeLine, oops, what is your name? All right, so slightly more exciting than hello world. All right, let's get rid of hello world. We'll ask the user what their name is. All right, well, now the question you might be asking yourself is, well, how do I actually ask them for their name? Okay, cool. So their name is going to be, what kind of data do you think? The name is going to be like an integer. Is it going to be a long? Is it going to be a byte? I think the thing that makes the most sense is string. So I'm going to make a variable that's going to hold what the person types in. So I think a string makes the most sense since they're going to probably type in letters. And char is like, I guess we'll get second place, but char is like a single letter. So if I have multiple letters, char will not work. So string is it. So I'm going to say string user input equals, and you can see like IntelliSense already did it for me, console.readLine. All right, and console.readLine is this more built-in functionality. Okay, we did not make this. It exists already inside the guts of the C# language. All right, what readLine does is exactly what it says it does. It reads the next line of characters from the standard input stream. In plain English, what that means is when someone types something into the console, it grabs it. Okay, and then after it grabs it, what does it do? It stores it inside this user input variable. Okay, variables are not quite like boxes, but I think that a box is a good mental image of what they do. It takes what the person, so this parentheses after here means we're doing something. Okay, so readLine is a method, and this means we're doing something. We are grabbing what the person typed into the console, and we are putting it in this box that we've labeled user input. And what kind of data is it? It's a string. Right, so line 3 has a lot to unpack, but once you see it work, you'll hopefully get a feel for it. So now on line 5, when you console.writeLine, and we're going to learn a new thing with strings today. You're able to put strings together with a plus sign. So we'll just put, for right now, we'll just do this. We also can do hello there plus user input. And what this will do is it will take the string hello there and then tack on whatever the person typed in at the end. So let's go ahead and run our program and see what happens. So notice it did line 1, which we see here, and we got to line 3, and currently the computer is on line 3 and waiting for the person to type something into the console. Has not gotten to line 5 yet. We're basically hanging out on line 3. So it's going to be that blinking cursor, and now I'm going to actually type something in. I'm going to put Jonathan, all right? And then after I type something in and hit enter, then it got to be line 5. And there it says, hello there, Jonathan. Okay, so this is really the point of variables. Okay, this is why they are called variables, because their values vary. User input is a box that held the value Jonathan. Okay, so when we got to line 5, it printed out hello there, Jonathan. So let me rerun this. And if I said Murgatroyd was my name, so what is your name, Murgatroyd? Then it would say hello there, Murgatroyd. And the reason that variables are useful is because this program can do different things based on what the person types. That's why we're using this variable here, user input. Okay, so I can put whatever they put in here. I can put Steve Rogers, and it'll say hello there, Steve Rogers. Right, that variable user input will represent whatever the person types in. All right, let's go over our code. On line 1, I'm printing out what is your name. The method writeLine prints out something to the console. All right, so give it a string, and it will print out to the console. Line 3, I'm going to ask the user to type something in. So console.readLine says, hey, I want you to wait until the person types something in and hits enter. Okay, you're going to hang out until the person types something in and hits enter. Whatever they type in, I want you to store inside this variable called user input. Again, a variable is kind of like a box. Not quite, but we can think of it that way for right now. It takes whatever they type in and puts it into this box. Okay, and I know it's a string because that's why I said it was. It's a string. User input is a string. On line 5, we only get to line 5 after they hit enter. So when we get to line 5, we do console.writeLine, hello there, plus user input. That way, whatever they type in gets outputted to the console. Right? This is a little small program, but as you can see, using variables and these built-in methods, we can do a lot of cool stuff. So now you can ask the user for all sorts of things, okay, and you're able to take what they type, put it in a variable, and then do what you want with it afterwards. All right, before we get into conditionals, let's talk about creating random numbers. All right, so C# has a lot of built-in functionality, and one of those things is a class called random. So in order to make random numbers, we're going to have to first make the random number generator and then ask it to make random numbers. So let's make the generator first, and all we're going to do is random, and I'm just going to call it random number generator equals new random. So this is probably brand new syntax that we've not seen before. So let me kind of break it down. Random, notice how like we've always done like string some variable equals Bob, right? So remember the type of thing always comes first. And thus far we've used string, int, float, etc. Well, there are other types besides just the basic ones. Like one of them is random. Random is a class. If you hover over it with your mouse, you'll see it says class system.random. System is like the guts of C#. It's like all of the source code for C#. All of that code that someone, other people at whatever time ago decided to write. Well, this is one of the things. It's a class. And we're going to learn later what classes are. But you can think of it like a type, like string or int. All right, so I have the type random, and the name of the variable, I called it random number generator. It could just as well be called potato, equals new random. I want a new random number generator. I like basically give me one off the assembly line. All right, cool. So now we're going to use this generator to actually make some numbers. So I'm going to just go ahead and console.writeLine. Inside the parentheses, I'm going to do random number generator dot next. Right, I said console.writeLine random number generator dot next. So this is that pre-built functionality, and we're going to see what it does. So we're going to run our program, and it prints out this number. Let's see, so 375,761,075. If we run it again, see how it gives us a different number? Okay, it gives us a completely random number. each time we run this. All right, so that's what next does. Next gives you a random number up to the limit of, I believe it's integer. Like, yeah, integer. So like the integer's maximum value is the highest number it can give you, and then it will just pick a random number. Now, that's cool, but we may want to have numbers within a range. Like I want like a random number between 1 and 10. Well, you can do that. Inside the parentheses for next, we're going to give it what's called arguments. Basically saying, hey, I don't want to do the default stuff that you normally do. Normally, you just give me a random number from 1 to however many numbers integers are allowed. Instead, I'm going to give you 2 arguments. I'm going to give you the lower number. Okay, so I want numbers from 1 to 10, so the lower number is 1. And then I'm going to give you the higher bound. All right, so I want a number less than 11. So the way you would read this is, I like a number that could, the lowest number that I want to allow is 1. And I want any number you generate to be less than 11. Okay, so this will give me a number between 1 and 10. 1 and 10. The thing you have to remember is that the lower bound is inclusive, the upper bound is exclusive. Inclusive and exclusive, remember, mean that, like, do we include the number in the range or do we not? So if I say 1 to 10 inclusive, that means it includes 1 and 10, right? If I say exclusive, then I exclude 1 and 10, and that means 2 through 9, all right? So this one's a little bit of a mix. The first number is inclusive, right? That's a lower one that says, okay, cool, start at 1 and then go up. The second number is exclusive, meaning less than this, not including. So less than 11, but not including 11. All right, so this will give me a random number between 1 and 10. Let's try it out. Okay, 6. All right, let's try it again. 10. All right, awesome. So as you can see, this gives us a random number. All right, so let's go over this one more time. Random is a class. If you hover over it, you'll see it says class. Random is a class, and we can use classes like types, just like string or integer. So I did random, and then the variable, I called it the variable random number generator equals new random. We're going to learn later what this new keyword does, but what this basically does is says, I'd like a random number generator, please. Can you just give me a new one right off the assembly line, nice and fresh? Let me have one. Then we take that random number generator, and we call it this pre-built method called next. Next, what this does is it basically rolls a random number. We can also customize next. We can give it 2 arguments separated by a comma. The first argument is what's the lowest number that you can generate, and then what's the highest upper bound exclusive. So 1 inclusive up to 11 exclusive, meaning it starts at 1, including 1, and it goes up to 11, but not including 11. So this will give us a random number between 1 and 10, and then when we run this, I take this console.write line, and this will run first, and then write line will take whatever it comes out of this next function and then write it to the console. So we can do that, and see we get 5, and if I run it again, it'll give me another random number. All right, so this is how generating random numbers in C# works. All right, so we have a really awesome thing called a debugger, which is included in Visual Studio 2022 and every Visual Studio for that matter, and it allows us to stop the program mid-flight. So far, when we've done our program, we've tested things, we just ran our program, waited for the console to pop up, and then see what happens. This can be a little bit inefficient. The debugger allows us to pause the program and look at what the program is doing at certain lines. So normally what you do, like we have some code here. I'm using the random class, I'm making a random number and saving it as random number right here, and then writing it out to the console, which we've seen before, right? And normally what we would do is we'd hit the play button, it would pop up the console, we would be able to see 7. You can also stop the code mid-flight. So I'm going to put a breakpoint, and you put a breakpoint basically you have this like blackish gray area over to the left of the numbers. You see how like a circle appears as you hover your mouse over it. So I can put a breakpoint. What a breakpoint does is it basically says, hey, I would like you to run the code up until, but not including this line. The not including part is very, very important. So let's put a breakpoint on line 5 and then run our app. Let's see what happens. Well, we had the console come up. It did come up, but look, the console doesn't actually say anything on it just yet. It's blank. And Visual Studio opened up, and then they have this yellow arrow, and this line here is yellow. That means that the computer has done everything before this line. The computer did line 1, the computer did line 3, now it's on line 5. It has not actually performed line 5 yet. It stopped right there. This is really cool because now we can kind of see what our variables are. So for example, let's say I wanted to see what the random number variable was. I can hover my mouse over it, and so you see it says random number is 7. So that means I've paused the program. The program is currently running, but it is paused on line 5. It hasn't run line 5 yet. Okay, it's just basically, as you can think of it, it's like stopped like right before it's ready to do line 5. And now I can use my mouse and look at like, okay, random number is 7. Oh, okay, cool. So random number is 7. And then if I hit continue, you'll notice that that's when it prints out 7, the random number. All right, so these debug points allow us to pause the program mid-flight, and then we can kind of examine things. It's really important to be able to use the debug mode and be comfortable with it, because a lot of times when your program doesn't work the way you expect it to, you need to be able to dig in and look to see like what's going on. Now let's work with this debug point a little bit so you truly understand how it works. You can put multiple debug points in. Okay, I run it, and notice how it stops on line 3. Now if I hover over random number, right now it says 0. All right, that's because this line 3 has not been performed yet. Even though it is highlighted and there is an arrow pointing to it, the computer has not actually performed this. The computer has not done it. So what you need to do is you can say, okay, cool, we can stop on this line, and okay, cool, I want random.next 1 through 11. You can continue the program by hitting continue, or you can hit this red square, and that will stop debugging and stop your program. All right, so I hit that. You see how it just stopped? It didn't even like continue, right? So I'm going to go back and run it again. Now, let's say I'm like, okay, cool, like I stopped it on line 3, and I want to move on from line 3. You hit continue, and it will go to line 5, the next breakpoint. If I hover over random number, now it says 1. All right. Why? Because it's actually, the computer's actually run line 3. It's actually done line 3. And line 3 says make a random number between 1 through 10 and save it as the variable random number. And now you can actually look and see what the value of random number is in real time. Now, if you look at the console, it hasn't written anything to the console yet. When I hit continue, it'll actually run line 5, and then you'll be able to see 1 on the console. All right, so again, debugging mode is really good. It's really great to be able to run your program and stop it. Like you hit the pause button. You put debug points, all right, you put breakpoints, okay, in your program on different lines. Now, when you put a breakpoint on a line, the program will start and will do all the code up until that line, but not including the line. It's a very common beginner mistake to think that the breakpoint actually performs the line itself. It does not. You can put your thing in debug mode by hitting the run button. You can put multiple debug points where there is code. Notice I can't really do it on line 4 because there's no code on line 4. If you would like to continue, you hit continue. If you'd like to exit debug mode, you hit the stop debugging mode. All right, give this some practice, and as we do the different lessons, you can run them in debug mode with breakpoints, so you can literally see the value of the variables, okay, and the value of different things as you run the program in real time. It helps a lot in trying to figure out where your code goes wrong. All right, so we can make random numbers and we can ask the user for input. So let's combine those two things and make a little bit of a guessing game. All right, so let's start on line 1. We're going to ask the person to pick a number from 1 through 10. So console.writeLine. Please pick a number from 1 through 10. Awesome, right? That'll print to the screen. And then we need to actually randomly create a number from 1 to 10 because we want the game to be different every time. We don't want the number to always be the same thing. So we're going to use random. Random equals new random. All right, and then we're going to do int random number is equal to random.next 1, 11. Remember, this random.next 1, 11 makes a random number beginning from 1 and then up to, but not including, 11. That is the weird thing about this. So remember, the first number is inclusive. The second number is exclusive. So this will give us a random number from 1 through 10. All right, and then we will do console.readline. And then actually, let's say this in the variable. So we're going to do string user input is equal to console.readline. All right. Now, this looks like a pretty good guessing game so far. We asked them a question. Well, now we didn't ask them a question. We just said to pick a number. We made the random number, and then they're going to type in the number, and then we're going to check. However, there's a couple of things that we need to be able to do from here. So it looks like the possibility is either the person guesses correctly or they don't. So there's two possibilities. Well, how are we going to tell the computer what to do under different circumstances? Because the computer should do something different. If they guessed the number correctly, the computer should say they won. If they didn't guess the number correctly, the computer should say something else. So we need to program the computer for all eventualities. It needs to know what to do in every single circumstance, or else the computer isn't going to do anything. And that's not good. We wanted to do something. So we need conditionals. And the conditionals are if statements, right? So we have one condition where the user guesses the random number. We say they won. And the second one is the user guesses wrong. We tell them, so sorry. All right, so to make the computer handle these two different possibilities, we're going to use if statements, okay? If, parentheses, and then we're going to put a condition inside. So we're going to do random number double equals user input, and then after the parentheses, we're going to do squiggly brackets. So if some condition, and then it will do whatever code's inside the squiggly braces. And again, just like for for loops, you can put as much stuff in here as you want. Now you notice that there's red on line 9. And let's hover over it. It says operator equals cannot be applied to operands of type int and string. User input is a string. This variable, user input, is a string. This variable random number is an integer. They don't match. If they don't match, you can't compare them. You can't use equals. So this double equals says that they're both equal. So if they're both equal, but the problem is user input is a string, we need to convert user input from a string to an integer. That way they could both be compared. Okay, you probably could turn random number to a string, but let's go ahead and take user input and turn it into an integer. All right, the way in which you can transform a string into an integer is to do int.parse, and then it will take parentheses. Notice how these parentheses keep coming up, right? So we have random.next had parentheses, and then we put stuff in there. Now we have int.parse with parentheses, and then we put this user input in there. Holy cow, look at this. Now that red went away. We have that green, which is a warning, which we'll deal with later. But for right now, we're saying on line 9, if the random number that was generated is equal to the user input, and take the user input and turn it into an integer. Take this string and turn it into an integer. So if the two are equal, meaning that the person guessed the correct number, then we are going to console.writeLine winner, winner, chicken dinner. All right, let them know they won. Okay, so we've got the first condition. Okay, the user guesses the random number correctly, and we say that they won. There's another condition that they're wrong. So we need to have the computer do something else if they're wrong. So if the random number is equal to the user input, we'll write line 11. Else, notice how else does not have parentheses like if does, right? Because else doesn't need it. Else says if it didn't happen from lines 9 through 12, then come down to here. So here we'll do console.writeLine too bad, so sad. All right, so if they guess the number correctly, and by guessing the number correctly, it means that the random number that we made is the same as the number that they put in, then we're going to say winner, winner, chicken dinner. Otherwise, else, say too bad, so sad, right? Because there's only two options. Okay, so if, else. So it means, so you could think of it like this. The computer will either run lines 9 through 12 or 13 through 16, depending on what happens. And this is great because now our program has some instructions for what to do under different circumstances. So let's run our game. And again, we're kind of assuming the person's not going to put like some random stuff in. All right, so let's say I do like 2. Too bad, so sad. I didn't get it. Let's play one more time. Winner, winner, chicken dinner. Okay, so 3 was the random number. Let's play again. Let's say it's 10. Too bad, so sad. So now every game plays a little bit differently. Okay, the number is random. We ask the person for what number that they think. And then if they win, we say winner, winner, chicken dinner. Otherwise, we say too bad, so sad. So that means that we are able now to tell the computer what to do under different circumstances. There's a couple things about this program that could go wrong, though. So, for example, what happens if the person just puts in, like, aardvark? Right? The user is under no rules saying that they can't put whatever they want in here. And if they put aardvark, well, I can't take aardvark and turn that into a number. So this int.parse is basically saying, hey, take this string, which is basically a number, and turn it into an integer. But what if they give us aardvark? Let's see what happens. We get an exception. The unhandled exception, unhandled system.format exception. And now we've crashed. So now our program has stopped. It's crashed. We have this horrible, gut-wrenching system.format exception, and we found a bug basically. All right, so how are we going to handle this? How are we going to make certain that the user gives us what we want them to give us? That's what we're going to handle in the next part. The one thing I tell all my bootcamp students is that the user is the enemy. Right? Yes, we make applications for users so that they can, use them for their lives and to make their lives easier and more convenient. But really, at the end of the day, the user is unpredictable. They will do what they will do, and we need to tell the computer basically like how is it going to handle all the different wacky things the user could do. Like take our guessing game. Right now our guessing game works fine if the user does what we expect them to do. What do I mean by that? So I expect that the user will type in a number from 1 through 10, and then I will be able to check that number against the random number that I generated. But there's no guarantee of that. So like if I do like 5 and hit enter, okay, cool, too bad, so sad. That's a normal thing to happen. But if I come in and open this up, and let's say the user just hits enter. Let's say they don't type anything at all and they just hit enter. Then what happens is we get an exception. An exception is a general computer term. It's not just for C#, right? But an exception basically is, in layman's terms, we ask the computer to do something, but it can't do it. All right. So things that could cause exceptions might be like dividing by 0. Right? Like we ask the computer to divide by 0. Well, that's not a thing anybody can do. So the computer can't do that. Humans can't do that. Nobody can do that. So if you ask the computer to do something impossible or like illogical, it will raise an exception. So in C# and Visual Studio, what will happen is that it will stop on the line that caused the exception. So right now you see that line 9 is highlighted in this like greenish gray, and there's a red X. That means that this line, there was a problem, right? Everything up until that point was fine, but then line 9 itself, there's a problem. And it's an exception unhandled, meaning that we don't have code to handle this situation. Input string was not in correct format. Let's hover over user input. If you hover over a variable while you're in this sort of debug mode, you can see what the value is. If we hover over user input, its value is these 2 quotation marks here. It's blank. Well, we told the computer to take user input and turn it into an integer. That's int.parse is what it does. Take this string and turn it into an integer. Well, how do you take a blank string and turn it into a number? Like, what number corresponds to blank string? That doesn't make any sense. So the computer is basically saying, I don't know what you want me to do with this. You gave me a blank string and told me to turn it into an integer. Well, I can't do that. That doesn't make any sense. Here, I'm going to stop the program on line 9. I'm going to pop up this message saying exception unhandled and let you know there's a problem. So here's the thing, though. Our program has crashed. Our program literally has stopped. Do not pass go, do not collect $200. Once this unhandled exception is raised, we're just basically like sitting here twiddling our thumbs because the computer can't move on. So if I hit continue, the program stops. Well, that's no good. Like, what happens? So now our program basically will run only if the user does what I want them to do. But we just saw that there's nothing stopping the user from breaking the rules. When I run the program, there is nothing to stop me from hitting enter here and not typing in anything. There is nothing stopping me from typing the word aardvark and hitting enter. Right? As the user, I can do what I want. So because of that, we need to have some way to account for that. Now, if statements are going to help us. All right. So now, if we go back to our if statement, our original thought was we have the user picks the right number, give them a message. The user picks the wrong number, give them a different message. We were living in a world where our guessing game only had two possible outcomes, right? There are only two branches, two paths that the computer needed to follow in order to do what we needed to do. But that was wrong. We were naive. There actually are more paths. So if we think about it, like the user puts in a blank line instead of typing anything. That's a possibility, right? Like I just showed you, I could just hit enter and then bam, like user input is a blank string. So we need to check to make certain that they gave us the correct input. So now we have three different possibilities. But we only have two. We have if and else. So if something, else is everything else. Well, we need three. So let's change this up a little bit and let's learn a new keyword. So the first thing I'm going to do is I'm going to check to see, did they give me a blank string? If, parentheses. Now we're going to learn a new method. Okay, this is another built-in functionality. We're going to do string dot is null or empty, and then put user input inside the parentheses. So let's talk about the string dot is null or empty user input. What this does is it's a Boolean. Okay, so this will give us a Boolean. This will give us true or false. If user input is blank or null or basically empty means like empty string looks like this. It's just two quotes. Like it's just quotes. There's nothing in it, right? So for example, string empty string equals. Okay, that's an empty string. There's no letters or numbers or anything inside of it. It's just an empty string. So if string dot is null or empty, user input equals true, then we'll tell the user you need to pick a number between 1 and 10. So we'll give them a message basically like letting them know that they gave us, you know, poor input. All right, that's a good thing to do. Like let the person know like, hey, you didn't do what we expect you to do. All right, so if string dot is null or empty user input equals true, then do line 18. In fact, we don't even need this equals true. We can do the nice concise way with booleans and just leave that off and just put if string dot is null or empty user input. It reads a little bit better. But now we've got this other stuff down here. All right, if we like to chain more conditional statements together, we can use else if. So in front of here, I'm going to change this from if to else if. So now we have if string dot is null or empty user input, console.write line, you need to pick a number between 1 and 10. Else if random number equals int.parse user input, then say that they won. Else too bad so sad. Well, this is a bit better now. We have three different conditions. All right, so we have three different pathways or trees that the program could go by, because now we're checking to make certain that, hey, like, did they actually like type something in here? If they didn't, we're gonna let them know like, hey, like that's not kosher, but the app will not crash. So if I run this and I just go here, let's say I just hit enter. You need to pick a number between 1 and 10, but notice how the application did not crash. Okay, we did not get an exception. It did not go into debug mode. There was no red X, nothing. It just basically just moved on with its life. So now we have a way to handle user input that goes against what we were planning, right? Remember, the user can do whatever the heck that they want to do. And the way we're able to do that is we have this else if. So I have if, else if, else. And you can have as many else's as you please. It could be if, else if, else if, else if. Like you have 10 else ifs if that's what the situation calls for. You have as many of these else if blocks as you'd like. All right, and then at the end, for everything else, you use the else block. Notice how if and else if both have parentheses and conditions inside, whereas else does not. Okay, that is a difference. So we have multiple else's, as many as you feel like, and then now our program is a little bit more robust. All right, if they put a blank string, they just hit enter, we no longer get that exception. We are able to continue to move on. All right, let's go further with these if statements because there's even more stuff we can do with this. All right, so far we have if, else. So if the user gives us an empty string for the input, like it's null or empty, then we tell them, hey, I'm sorry, you need to give us a number between 1 and 10. And if they win, if the two numbers are equal, they win. If not, then we say too bad, so sad. All right, so what if we wanted to tell the user whether or not they got too high or too low? All right, so like, for example, if the number were 5 and they guessed 7, we give them a little chance to like, hey, you got too high, like you guessed too high, or they guessed too low. All right, so we're going to add a couple more conditions. So let's do another condition. All right, so we still check to see, hey, did they give us a blank string? Because if they gave us a blank string, it's not going to be much of a game. We'll give an exception. All right, cool. If they win, if it's like they get exactly the number, then they win, and we tell them. All right, now we're going to do else if. Now this condition is going to be, hey, if the number that they guessed is higher than the random number. So what we're going to do is int.parse user input. Okay, so again, we're using the same technique we have here, all right, to take the string user input and turn it into an integer if it is greater than the random number. So now you may remember this greater than sign, okay, from math. If not, greater than just basically compares two numbers. As a kid, I would always remember that the alligator eats the bigger number. So the open part is pointing towards the side that's bigger. So int.parse user input is greater than random number. So else if it's bigger, we'll say console.writeLine. Okay, you went too high. All right, so you went too high. So instead of just doing equals, we can do this greater than. So you have other symbols you are allowed to use. So we can use equals for when the two things are equals, or we can do not equals. All right, so we have exclamation point equals means not equal. All right, so we also use greater than or less than, or greater than or equal to, or less than or equal to. Right, so we have all of these different conditions we can put in here. So for example, we also could do else if, we could flip it around and say if it were less than, then we could change the, maybe you went too low. All right, so this comparison is awesome because we can do different kinds of comparisons. Let's go over them again. We've used double equals if they're equal to each other. If we say exclamation point equals, it means they're not equal to each other. Greater than, less than, greater than or equal to, less than or equal to. All right, so we're going to put it back to the way it was. So we're going to say, hey, you guessed too high. Now, think about it. Since the else covers every other option, we don't need another else if for less than. We could just basically assume that if it got all the way down here, it was less than. So you went too low. All right, so let's run our game. Let's see how it looks. It's building, compiling. All right, pick a number from 1 through 10. We'll put 3. You went too low. Let's do 6. You went too high. All right. Let's do 5. That was it. Winner, winner, chicken dinner. If we play again, say 10. You went too high. So now, not only does our program tell us that we won, it also gives us a hint as to whether we went too low or too high. And so we were able to use greater than in order to basically say that. So to recap, inside your if statement, you have a condition. The condition does not have to just be equal. So far in the original example, we used two equal signs to say one side is equal to the other. But there's other ones. You can use not equals, and so this exclamation point means not. So if they're not equal to each other, or greater than, less than, greater than or equal to, or less than or equal to. So in this example, we basically did, okay, cool, like what happens if they guess the number that's too high? Well, the number that they guess is greater than the number that was randomly generated. We tell them it was too high. Otherwise, we tell them it was too low. So now we've got even more if statements. So if, else, which is great. And that's normal. Like there's nothing wrong with having that. So now our program does a lot of different things depending on whether or not how they guess. So our program is very, very versatile, meaning that, the game will be different every time the person plays. All right, you guessed it. We're going to keep working on our guessing game. So we were able to learn about how to use like equals, not equals, less than, greater than. But what if we have more than one condition, right? Like what if, for example, we have, our game is great, it's popular, everyone's playing it. But then they want to say, okay, if the random number is 7 and the person gets it, then we want to display a really special message because it's like lucky number 7, then they get like double points or something like that. All right, so this will not really suffice. Like this does tell us like that they won, but we have another condition that we also want to check for to see if the number is 7. So you can do that. So if you have multiple conditions for one if statement, we're gonna learn a new one. So there's basically two. There's and, which is signified by two ampersands, or there's or, which is this like pipe. So you have two of them. All right. So if the random number is equal to what they put in, and the random number is equal to 7, right? Then we're going to change this message to console.writeLine, you guessed correctly, lucky number 7, double points. All right, instead of our normal message, winner, winner, chicken dinner, all right? So if they get the number correctly and the random number was 7, all right? Otherwise, else if random number equals int.parse, user input, just like normal, and random number does not equal 7. Okay, remember this exclamation point equals means not equals. Then we'll just put winner, winner, chicken dinner. So to get this super special message, the random number needs to be 7, and then you also need to guess it correctly. I'm going to do a little cheating here, and I'm going to just make sure that the random number is 7 so we can see it work. That we don't have to run the program a gajillion times. So line 13 is me cheating. All right, so I'm going to go ahead and run it. All right, and then I'm going to put in 7. It says you guessed correctly, lucky number 7, double points. All right, so it looks like it does that. So let's take out my little cheating code, and I will run it normally, and let's see if we can get a winner. 3, I went too high. Oh, that went too high that time. All right, 2, went too low. All right, let's do a little more cheating. I'll do random number equals 5. Okay, so I'm cheating. I'm setting it myself so I know what it is. Put 5. Winner, winner, chicken dinner. So now you see that if the number is 7, we display a special message. Otherwise, we display it winner, winner, chicken dinner. So this is where we can have multiple conditions. Let's review. If random number is equal to int.parse user input and random number equals 7, that means these both have to be true. This has to be true, random number equals 7, and this has to be true. Okay, awesome. We also use and here. If random number equals int.parse user input and random number does not equal 7. Okay, so we can use and in order to string multiple conditions together. Now, how many ands can you use in an if statement? As many as you feel like. It might make it difficult to read, but again, there's no rules. Now, the other one is or, where it's this is true or this is true. All right, so the big thing with and is that these both have to be true. If either one of them is false, it will not do line 19. If either one of these is false, they both have to they both have to evaluate to true. If there's an or, either one can be true. If this is true or this is true. One could be true and one could be false, and that's okay. With and, they both have to be true in order for it to go through. Right? So now we can use multiple conditions inside our if statements. Remember, we have two ampersands to do and, or we have the pipe, okay, to do or. Okay, and we can string as many of them as we want. In our game, I'm checking to see that the user picks the right number and that the number is 7. If it is, I get them a special message saying lucky number 7. If they guess the number correctly but the number is not 7, then they just get winner, winner, chicken dinner. All right, let's do loops. So there are two kinds of basic loops. So we have for loops and we have while loops. All right, so let's do for loops first. So a for loop is used when you want the computer to do a certain thing a certain number of times. So the idea is that we want the computer to, I don't know, print something to the screen 3 times, or you want the computer to go through the number, all the students we have in our database, and there's 10 of them, right? So the for loop is for a set number of times you want to do something, right? That's what differentiates it from a while loop. For loops, the actual syntax in C# is not that difficult. We're going to do for, surprise. Now we're going to have 3 things inside these parentheses. The first is a placeholder variable. Typically people do I, but you don't have to do I. You can, forge your own path and do your own thing. But we're going to declare a variable. Int I equals 0. Now what's the purpose of this? We'll see in a moment what I is doing, but I is like a placeholder. So as we loop through things, we need to have some way to know like which loop are we on. Are we on the first iteration? Are we on the 5th iteration? Are we on the 10th? Like how many times have we done this for loop? This variable I will keep track of like how many times have we done the for loop so far. The second thing we're going to put inside the parentheses is what condition do we want the loop to continue. So let's say, for example, I is less than 5. That means this loop will continue and go over and over and over again until I reaches 5. So if I is 0, then the loop will continue. If I is 4, the loop will continue. If the I is 6, the loop will not continue. So this lets the computer know, hey, this is when I want you to stop the loop. All right, at the end of the loop, what do you want the computer to do with this variable I? I would like to take I and move it up by 1. I'm going to put some curly braces, and then we have a basic for loop. All right, let's go over these 3 parts again. The first is a placeholder variable. Int I equals 0. It's usually an integer. You can have this be j, you can have it be k, you can have it be aardvark, it doesn't matter. Typically people just use I because it's 1 letter and easy to type. Then, what circumstance does the loop continue? Okay, this is called the condition. All right, essentially, as long as I is less than 5, we'll do whatever is in between these 2 curly braces. So the for loop has these 2 curly braces, and then you can put some code inside of here. And what this means is I will do that code so long as this remains true. And then when it reaches the end, I++. So I'm inside the curly braces, so in between line 3 and 5, I'm going to do console.writeLine I. And that will write the value of I to the console. Now you can have as many lines of code in between these curly braces as you so feel like. It is up to you. I'm putting 1 line just because I want to show a simple example, but you can do between these 2 curly braces you can do as much code as you feel like. All right, let's run this and let's see what happens. It's compiling. All right, so if we look on the screen, it shows 0, 1, 2, 3, 4. I'm going to hold up the output and compare it to the code. All right, so here's what happened. The loop starts. The computer gets to line 2 and says, okay, cool, we have a for loop. I'll make a variable called I, and it will start off at 0. Then, is 0 less than 5? Yes, 0 is less than 5. Cool, that means then the computer will say, cool, this part's true. It will then go to line 4 and do whatever is on line 4. Whatever is in between these curly braces, it will do. If it's 10 lines, then we'll do all 10 lines. If it's 1 line, it will do 1 line. Whatever you have in there, the computer will do. So I said console.writeLine I. That was this, 0. Cool. The computer got to line 5. The computer's like, okay, cool. Take I and increase it by 1. That's what this I++ is doing. Take I and increase it by 1. Well, we're still in the for loop, so we go all the way back up to line 2. So the computer went from line 2, then did line 4, got to line 5, it said, okay, I'm still in the for loop, and then went back up to line 2. So basically, we're going to have the computer go back and forth between line 2 and 5 over and over and over again. It'll go 2, 3, 4, 5, then back up to 2. Then 2, 3, 4, 5, then back up to 2. Over and over and over again until this is no longer true. All right, so if you look at the output, first I was 0, then I was 1, then I was 2, 3, 4. All right, so let's do 4, right? So I was 4. Console.writeLine, then did I was 4, it got to line 5. It increased I by 1. It went from 4 to 5. Then it said, okay, cool, we're going to go back up to line 2 and start the for loop. Oh, wait a second. I is 5, right? 5 is not less than 5. If I take this I and replace it with 5, right? This is not true. Okay, this is not true at all. Like 5 is not less than 5, 5 is equal to 5. So because that's no longer true, it doesn't continue the for loop. So you break out of the for loop, and then it will continue on. So I'm going to put some code here, kind of demonstrate that point. We've exited the for loop. All right, then I'm going to run it again. All right, see how all these numbers appeared on the console first, then we had line 7? That's because the computer has been doing lines 2 through 5 over and over and over and over again, and it couldn't move on until after the loop was broken. So once I was equal to 5, the loop was broken, then it could get to line 7. So for loops are a great way for us to be able to do code over and over and over again. So that line 4 got run 1, 2, 3, 4, 5 times. Okay, I wrote one line of code, but the computer ran it 5 times. That's really efficient. I don't have to write like console.write. Like this is way better than having to write console.write line 0, console.write line 1, and then have to do that for like all 5 of them. That'd be very, very, very like tedious to do. All right, instead, what I'm going to do is I'm going to have it just loop through 5 times and then just do this code. This is what we want to do in code. We don't want to like write out in a tedious manner that's going to like hurt our brains. We would rather have the computer give us convenient ways of doing something. So a for loop is a very convenient way of telling the computer to do code a certain number of times. All right, so again, to review the different parts, we have the for command, so we have for parentheses, and then we declare a placeholder variable, and we just chose I because we chose I out of a hat. We could call this hat. Like literally, if you went through and changed I to the word hat and ran it, it will look exactly the same. The variable has no magic powers. It's just a label. We can label it whatever we so feel like. So we just pick I because that is tradition. That's all. All right, so we have a placeholder variable. I called it I. Then I said this loop will run so long as I is less than 5. Okay, I want this loop to continue so long as I is less than 5. When we get to the end of the loop, I want you to take I and bump it up by 1. All right, so we had for int I equals 0, I is less than 5, I plus plus. Now, the for loop has this inside of it, which is these curly braces, and it will do whatever code you write here. So you can do console.write line, and then again, you can have more than one line. Console.write line. Hey, what's up? I'm in a for loop. Okay, you have a million lines in between these two things. Up to you. If I run it, see how it gets. So the first loop, it printed out these two. Then the second time around, it printed out these two. Then the third time around, it printed out these two. So now I can have the computer do something multiple times. It'll do it over and over and over again until I tell it to, forever many times I told it to do something. All right, so that's how for loops work. Okay, and again, this is the syntax. My personal advice would be if you're having problems understanding for loops, the first thing you got to do is get this syntax down and not be thinking about it. It's always going to be in this basic order. It's going to be the placeholder, the condition, and then I++. You also can do I minus minus if you'd like. All right, but get this, type this out a few times and practice it. All right, and that's basically for loops. We'll talk about while loops next. Now, while loops look a lot like for loops. The main difference is that for loops is about doing something a certain number of times. What I mean by that is the code inside of the for loop, you would like to run that code like 5 times or 10 times or 20 times or whatever it is you need to do. A while loop is less about the number of times and more about when do you want the computer to stop. So essentially, you would like to perform some code over and over and over again forever until you tell the computer to stop. You don't care about how many times it goes. Maybe it's like 100. Like the amount of times it happens is irrelevant to you. You just want to let the computer know, hey, stop at this point. That's the difference between for and while loops. Let's do the syntax first. So as you may have guessed, it's got while and some parentheses. And then we need to make I'm going to make a variable, but I can't make it inside the while loop. So for example, I cannot do it like int j equals 0 inside the while loop. Okay, that's not kosher. All right, j, this variable, needs to be declared or brought into existence before line 11. So I'm going to do int j equals 0. All right, and then I can use that variable for my while loop. So while j is less than 10, let's say. All right. So what this while loop means is like, hey, while the variable j is less than 10, do whatever in between these curly braces. So you'll notice that the for loop had curly braces, right? That means this is the beginning and end of the for loop. It's the same concept for the while loop. Here's the beginning and then here's the end. All right, so while we're in here, we're going to console.writeLine. Let's switch it up. J is equal to plus j, and then we'll do that. And then at the end of it, we're going to do j plus plus. Now you're saying, Jonathan, this looks like totally like the for loop above. I'm like, yeah, it kind of does. So I'm going to comment this other stuff out so we can see just our while loop stuff, and I'm going to run it. And as you can see, we're going to compare. We got 10 lines of output, but we only wrote a while loop, which only went from lines 11 to 14. But we had the computer output all this stuff, which is cool. All right, so let's run through how it works. While j is less than 10, so at the very beginning, on line 10, we said j is equal to 0. Okay, j is 0. We get to line 11. Is 0 less than 10? Yes, 0 is less than 10. Then it will do lines 12 and 13. So line 12, j is equal to 0. Then we did j plus plus, so j went from 0 to 1. Remember, plus plus means go up by 1. All right, we got to line 14, and then we went back up to line 11. Okay, at line 11, is 1 less than 10? Remember, after the first go around, we did j plus plus, so j was 0, but now it's 1. So is 1 less than 10? Yes, 1 is less than 10. And then it will keep doing this over and over and over again until we get to, like, see how it prints out 9 but doesn't print out 10? Because we got to 9, so it printed out j is equal to 9. Then we did j plus plus, so 9 went to 10. J went from being 9 to being 10. And then when we got back up to line 11, 10 is not less than 10. That's not a true statement. Okay, 10 is equal to 10, but 10 is not less than 10. So because that statement is not true anymore, the while loop stops. Okay, once this condition is no longer met, the while loop ends. So you're probably thinking to yourself, Jonathan, these look basically the same. Like if I just made this 5, okay, how is this any different from the other for loop? All right, so if I just let's say I run both of these. Right, like 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And in this way, they can be used in a similar circumstance, right? So this would be a case where they're basically the same thing. You're thinking, okay, well, Jonathan, why are there two different things? Typically, you'll use a while loop more for a condition that you don't know necessarily when it's going to stop. And I will give that to you in the next video. We're going to actually construct a situation where we would use a while loop more so than a for loop. But let's just make sure you understand the while loop. So we have while, and then the variable inside some condition. Remember, the variable has to be declared before the while loop. It's not like a for loop where you can declare the variable inside the for loop. All right, so j is less than 5, and then between the curly braces we have some code. All right, and then it gets to line 14 and comes back up to line 11. It will just basically be a circle and go over and over and over again until this condition is no longer met. Now, one little piece of advice. The while loops can be very dangerous because, for example, let's say I forgot to put j plus plus here. Let's just say like I fat fingered it and it's like the comments or someone forgot this and I try to run this. See how it just keeps going and going and going and going and going? That's because like we haven't told it to stop. Okay, because j is 0, right? 0 is less than 5. It does line 12. If there's no j plus plus here, j just stays at 0. Therefore, this is always true. Therefore, as you can see, this loop goes forever. All right, the for loop is a little bit safer in that we tell it like I plus plus in it, so we know that I is going to go up or down depending on what we do. With a while loop, if we don't have that there, this while loop will, as you can see, this will go on literally for all eternity. All right, so just be careful to make certain that you can actually exit your while loop. But let's construct a situation where a while loop really kind of shines. All right, here is a good example of when we would use a while loop as opposed to a for loop. All right, so I've got a Boolean. I said bool game is running equals true on line 1. This is just a Boolean. Remember, Booleans are true or false. And then I did while game is running equals true. You also could write like this. If you don't want to write the equals true, you could just write it like this because Booleans can be written shorthand. So this is equivalent to writing equals true. All right. If you want to write false, then you would put an exclamation point in front of it. That would be false. But I like to have everything nice and spelled out, so we're going to put double equals true. Alright, so the first thing that the computer is going to do is going to write this line to the console. Type Y for yes, type N for no. So let's say we're like playing some sort of game, right? And the game runs until the person tells us to stop. So this is a great example of using a while loop because, again, we want the program to run until the person says to stop. So do we know how many times it's going to run? No, I have no idea. Maybe the person will play the game 10 times, 20 times, 1,000 times, 1 time. I actually have no idea how many times they're going to play the game. I just will want to have the game stop when the person says, types in N. So it's not going to be much of a game. There's not much in it. But I want the person to type Y if they want to continue the loop, and N if they want to stop. All right, line 6, if you remember, is going to grab what the user types in the console and save it in a variable. So I did user input equals console.readLine. And then if user input is N, then do this. Right, they're going to say you are free from the while loop, and we're going to do break. Break is a new keyword. What break does is it stops the while loop. Okay, you could do break, or we also could do game is running equals false. And we'll do it this way. They accomplish the same thing. Okay, break basically means just stop the loop. Okay, whatever you're doing, just stop it. But I'll make game is running equals false to kind of show you like how to kind of reinforce what's happening up here. All right, so let's run this. All right, so it says type Y for yes, type N for no. I'm going to type Y. All right, so notice how it goes back. So like right now we're on line 5. Okay, so line 5, I printed that out. Line 6 is waiting for me to type in something. All right, let's say I type in Y. And then, okay, cool, type Y. It went all the way down to line 13 because I didn't put Y in, so it skips line 8 through 12. Gets to line 13, then goes all the way back up to line 3. Game is running, it's still true, so we start back on line 5. And this will continue forever. If I just type Y, it will do this over and over and over again. Now watch what happens when I type in N. So on line 8, I say, okay, cool. If the user types in a lowercase n, you are free from the while loop. And notice how the program stopped. All right, we broke free from the loop. So this is a great case for a while loop because you can have the user type as many things as you want. Maybe I did it 1, 2, 3, 4, 5, 6, 7, 8, 9 times, right? We don't know how many times the user is going to do this sort of thing. They could do it once and then quit out. That's possible. They could do it 3 times and then quit out. Okay, a for loop, we have to kind of know how many times we want to run the code. Maybe they have like 10 times. Like maybe we say, okay, cool, we're going to count up from 1 to 10. That's a set number of times or set numbers. While basically says, hey, just do it until I tell you to stop. You can think of it like someone filling up your glass, like, getting a refill, and you just like say, okay, cool, we're good. All right, like the while loop is basically saying, you tell me when to stop. I'll keep running the code. I'll keep filling your glass up with water for as long as you tell me. And then the second you don't want me to do anymore, you tell me to stop. So if we look at our code again, I have a Boolean called game is running equals true. Okay, line 3, it will check to see, hey, if game is running equals true, which it initially will, it will run what's inside the while loop. So it will print this out, it will ask the user for information, and then if the user's input is lowercase n, it will exit out by writing this line and then making game is running equals false. Remember, if game is running equals false, it'll come back up to the line 3, and this won't be true anymore. If game is running equals false, then this is no longer a thing, right? This is not, the while loop is not satisfied anymore, so the while loop will stop. That's why when I run it, if I type in Y, then the variable game is running is still true. The second I hit N, game is running will be false, and therefore the while loop will stop. It will exit the while loop. All right, so this is great example of when to use a while. So a for loop would be very, very, like, you need to like count up or count down from something, right? That's the whole point. Like I could have them do something similar to the above code, but the problem is I need a set number of times. I need a number, 20, 100, 50, all right? This does it over and over again until I tell it to stop. The number of times it actually does things is irrelevant. I don't really care. I just want it to do it until the person tells them to stop. This is a bit difficult to grasp for some beginners, but try to like think about that. All right, like one is like filling up a glass, having the person say stop. This is like how many orders how many of X do you want, right? That means the exact number, right? So that should hopefully give you a better grasp of the difference between a while loop and a for loop. All right, let's work with strings first. Strings are a common thing you'll be working with, so you'll need to be able to handle them. First, let's do some string formatting. So I have a very simple program that asks the person their name, they type their name in, and then it says your name is whatever they typed. Not the world's most exciting program, however, it will work. We're going to just assume that the user is going to give us reasonable input, okay? So that makes it much simpler. All right, so they type in their name, it puts out their name. Now notice on line 5, I have a string, your name is. Remember, the double quotes indicate that it's a string. So this whole thing is a string, this whole highlighted part. And I did plus and then user input. So what this will do is it will take whatever user input is and add it at the end of this string. And user input itself is a string, so this plus sign will put these two together. Now, if you just use a plus sign with numbers, it would add the numbers, but this is a string and this is a string, so it will just combine them together. Let's see how that looks. So, what's your name? My name is Wanda Maximoff. Right? Your name is Wanda Maximoff. So notice how it just took what they typed and appended it to each other. So now that they're stuck together. You don't have to do it like this. There's another way you can format your string to include variables inside it. The way to do that is string interpolation. So in front of the first string, I'm going to put a $sign, right? Just like this. You're going to be like, why the heck are we putting a $sign here? Well, instead of doing this plus user input, I'm going to get rid of that. And I'm going to do curly braces. Notice how these curly braces are not orange, like everything else in this string, right? So the $sign is orange, the string is orange, but this part's white. This indicates that, hey, we're going to actually stick a variable inside here. I'm going to put the variable user input, all right? And then you'll notice that we have a new string. We start off with $sign. We had our your name is, and then I put the part where that's going to be the variable, and I put that inside curly braces. So curly braces user input, and then now if I run it, it should be exactly the same as it was before. All right, what is your name? T'Challa. Okay, your name is T'Challa. Right? It was able to essentially intersperse or put the variable inside the string. It did, the output's the same as if we used the plus sign. So we did like this, like we originally did it. So if I did your name is plus user input, then it gets the same result. Those are just basically two ways of doing the same thing. So sometimes you'll use the plus, sometimes you'll use the $sign with the curly braces. You get to choose. The end result is the same. Sometimes in programming we can do one thing multiple ways. You may find that using the $sign and the braces will make a lot of sense if you have lots of variables inside your sentence. So for example, let's say we had more things, like, let me change up the program a little bit and then I'll show you. Alright, so I've added some more stuff. So we have what is your name, what is your quest, and how old are you? So now I'm asking multiple questions. Alright, notice I have variables that will hold the different things that the person will input, and now I want to have a sentence with all three of these variables in it. So it's like your name is, so I did it with just pluses, it would be like this. Your name is plus user input, and your quest is plus quest. I call it user quest. There we go, user quest. Plus, and you are plus user age plus years old. All right, this is fine. This will work. So let's run the program. What's your name? I don't know, Steve Rogers. Steve Rogers. What is your quest? Save America. How old are you? I think he's like 100. All right, your name is Steve Rogers, and your quest is Save America, and you are 100 years old. Got to put a little space in there. All right, so put a little space in there. Now, if we wanted to do this with the interpolation way, instead of doing all these pluses, which gets kind of, let's go back and combine everything. Okay, so let's get rid of this first part. just going to get rid of it. And you are this. Okay, so right, so start with a string, and now we can just go ahead and use curly braces. Your name is user input inside curly braces, and your quest is user quest inside curly braces, and you are user age inside curly braces. And so now when we have like a lot of variables we want to put inside of the same string, this is a lot like cleaner. It looks a little bit cleaner than having all those plus signs. And then will work just the same. What is your name? Vision. What is your quest? Weird philosophical ramblings. How old are you? And things like, what, 3 years old? All right. And so you can see that it basically does the same thing, although I mess with the sentence, but you get the point. But so now that's why you would use this over the plus signs, is because this is a lot cleaner looking when you have lots of different variables. All right, let's do some built-in functionality with strings. All right, so C#, as we've seen before, we saw why we had a random class. We also have that string.isNull or empty. There's a lot of stuff in C# that's already written for us that we get to use to help us build better programs. This is great. So we're going to learn about string methods. Okay, a method is just basically a pre-built piece of functionality. There are some methods that are built into C#. They come with the C# itself. We don't have to do anything. We just get them. And then later on in the course, you'll learn how to make your own methods. Okay, you can make custom methods. We're going to use methods related to strings. All right, so I've got a very simple program. I ask the person for their first name, and then they input it. And again, we're going to assume the user is going to give us reasonable input. Okay, what if I wanted to make the thing that they type in all uppercase, for example? All right, so I'm going to do user input, which is a string. Remember, the type comes first. User input is a variable. The type is a string. Now, if I do dot, you're going to notice that there's a bunch of stuff that pops up with this like purple, like cube-looking thing. All right, so the ones that have the purple without the arrow are methods that are related to strings. So you can think of it this way. Strings, like when people made C#, there were a lot of things that developers did all the time, and then they wanted to be able to do it over and over and over again without having to write their own code. So the people who made C# were like, okay, fine, no problem. We will go ahead and just allow you to use these methods. So let's use one of them to upper. All right, so we're going to type, you'll see it's in the list here. It's got the purple cube next to it, and we'll just say to upper, and then we will include parentheses afterwards. All right, and then we will console.writeLine user input. All right, let's see what happens. All right, I'm going to type in a name, all lowercase. I'm going to call it James. All right, now, as you notice, it's pretty much the same, right? So this to upper, right, doesn't actually change user input itself. So we're going to actually get rid of line 5, and we're going to do user input dot to upper. And don't forget the parentheses, because it is a method. This parentheses basically says, okay, do this method. All right? If without the parentheses, it's just nothing. Like, for example, if you were to just do this, okay, you'll get red squigglies basically saying, like, what on earth is this? You want to do parentheses afterwards to call the method. Okay, so I'm going to use that term now to call the method. All right, so let's run this. Let's see what happens now. I'm going to put James in now. See what happened? All those letters were uppercase now. Now, you may be saying, well, Jonathan, I don't remember writing any logic, any for loops, anything that took what they typed in and made it to uppercase. And I would say you don't have to, because C# comes with this to upper method that comes attached to strings. Because user input is a string, you get this to upper method. Notice how if I have another variable, let's make it int, some integer equals 0. I do some integer dot. Notice how to upper doesn't appear in this list. Okay, there's to string, there's get type, there's compare to, there's a bunch of other stuff, but there's no to upper. Okay, the reason for that is integers do not have a method to upper. It doesn't exist for integers. This method exists for strings. Okay, so depending on the type of variable we're using means we have different built-in functionality. And that makes a lot of sense. Strings are very different from integers. like, what would it mean to make an uppercase integer? Doesn't make any sense. So strings have their methods, integers have theirs, etc., etc. All right, so we have to upper, and then the opposite, of course, we have to lower, because you've already may guessed. All right, so if I give it all capital letters, or just say, let's say, tell me your first name, Agatha, and right, there we go. So I made all lowercase. All right, so these pre-built pieces of functionality are really cool. Okay, so we have to have user input dot to upper and user input dot to lower, right, in order to make everything uppercase or lowercase. Okay, there's of course a lot more we can do. So as you can see, there's quite a few methods. Okay, again, you're looking for the purple cubes without the arrow. The other ones we'll learn a bit later. Okay, another one that is pretty cool to use is we'll use it with the if statement. All right, so let's change this up a bit. Let's say the person tells us their name, and their name begins with the letter J. All right, and if the name begins with the letter J, we want to give them a special message. All right, so that sounds like an if statement. So if user input. Now we could do a bunch of really, interesting things to try to figure out if the first letter of the word they put in is J. But there is, of course, a really cool method called starts with. Okay, starts with does exactly what it sounds like. Okay, if we look at the signature, if I hover my mouse over starts with, it gives us what's called the signature. All right, it says string dot starts with. Remember I said that this is a method for strings. He has a string dot starts with. That means it starts with belongs to a string. All right, and it expects a char. Okay, so inside its parentheses lets us know, like, hey, this is what the method wants from us. So let's put a char in here, which is single quotes, and let's put J. So if user input that starts with J, we'll console.writeLine, hey, you're part of the J fam. Right, so if their name starts with J, we'll say, hey, you're part of the J fam. Otherwise, else, we will write, your name does not begin with a J. All right, so we're using our if-else statements now, which starts with. So on line 5, I did user input. Remember, that's what the person types in. It's a string, so I can do dot starts with, and then inside starts with, it takes a char. Okay, remember, char is different than string. Char is a single letter. Let's run the program. Tell me your first name. I put James in here. Hey, you're part of the J fam. All right, let's run our program again. If I put like Emily, your name does not begin with a J. All right, so you can see that starts with lets us know whether or not the string begins with the letter J. Now let's see if it's case sensitive. Let's put James, lowercase j. Okay, so you'll notice that it is case sensitive. Okay, yes, I put James, and James does begin with the letter J, but on line 5, I put uppercase J here. All right, so it is also caring about the case, not just the letter itself. All right, and we can also do the opposite with, and you probably have already figured it out, ends with. Okay, let's say it ends with, I don't know, N. So, hey, your name ends with N. Let's make it lowercase because that makes more sense. And your name does not end with N. Okay, so starts with is looks at the first letter, and then ends with looks at the last one, as you could probably guess. So let's try it out. Let's put my name, Jonathan. Hey, your name ends with N. Awesome. Let's try McGillicuddy. Your name does not end with N. So now starts with and ends with are really cool ways for us to be able to test whether or not a string begins with a certain letter or ends with a certain letter. And again, case sensitive, right? So to recap, we have user input, which is a string. Okay, we put dot, and then after we put dot, we're given a whole list of methods that are attached to strings. Remember, strings have certain methods, integers have certain methods, booleans have different methods. They're all depending on what we want to do with them. Okay, we learned to upper. Okay, so input dot to upper will turn something uppercase. To lower, we'll make it all lowercase. We also have ends with to check the last letter of the string, or we have starts with to check the first letter of the string. Okay, so now we have all these cool methods that allow us to do cool things with our strings. All right, let's continue working with strings. So I've got it's kind of a silly program, but it'll get the job done. I've got basically telling the user to just give me a really big string, and then I will store it in user input. All right, so now we're going to see what more things we can do with strings. So let's say, for example, I want to take this string and replace one letter with another letter. All right, so I'm going to do user input equals user input dot replace, and then parentheses, and then replace will take two arguments. So I hover over replace, it says string dot replace char old char, char new char. All right, so what replace does is says, okay, cool, what do you want me to look for? Look for the letter A. Okay, cool, once I find the letter A, what do you want me to do with it? Replace it with the letter L. All right, so user input will take the letter A anywhere inside the string and replace it with the letter L. Then I would like to console.writeLine user input. Yes, IntelliSense, creepily good. All right, so let's go ahead and try this. I'm typing the word alfalfa. All right, and let's see what happened. Okay, so I typed in alfalfa, user input at that line 3 is equal to alfalfa. On line 5, I say go ahead and take the word alfalfa, find every lowercase a, replace it with lowercase l. So you can see the way that they're lined up, you can see the replacement. A got replaced with L, this A got replaced with L, same here. All right, so replace is kind of cool because you get to like replace one letter with another letter if that's what you want to do. You can even do it with like blank stuff. So let's say I want to replace like A with blank. Let's say I want to just leave everything blank. Like, see, I have this blank space here. So I'm going to try it. Alpha. And notice how instead of A, there's just blank space here. Right? So now we know how to use replace. Okay, we have this whatever string you're working with, dot replace. What are you looking for? What do you want to replace it with? All right, perfect. All right, what if I only want part of a string? Well, let's say I have like a really big string and I only want like a section of it, like one little part of it. All right, so what we're going to do is I'm going to get rid of line 5. All right, and then we're going to learn substring. Okay, dot substring. And substring also takes two arguments. We're going to put two things inside this parentheses. One is the index. So here's the thing we have to know about strings. Actually, let's take a step back and let me show you something about strings before we get to substring. All right, let's learn length first. All right, length is how many characters there are in a string. All right, so for example, let me run this and let's put a 3-letter word in. So I'm going to put in like eat, and out came 3. That means that there are 3 letters in eat. All right, so length tells you how long the string is. Now, blank spaces do count. So if I rerun it, let's say I did eat, and then I hit space bar, eat more, I don't know, healthy food. So notice how there's like spaces in between these words, right? So it gave me 21. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 total, including the spaces. All right, so string.length tells you how long the string is, right? How many characters it is, and the blank spaces do in fact count. Now, what you need to realize is that we have this thing called index, which all index is a fancy way of saying position. All right, so in C# is a 0 index language. What that means is whenever we look at the position of something, the first thing we're looking at, like the first thing in the list, is always 0, not 1. When human beings list things out, they always start with 1, right? Like, what's the first thing on your grocery store list? Okay, because human beings are 1 index. So when you make a grocery store like list, you go shopping and you like number your list. You don't start with 0, you start with 1. So 1 apples, 2 potatoes. But in C# we start with 0. Our lists begin with 0. That's the way you can kind of think of it. So this string, eat more healthy food, right, has a bunch of letters at different indexes. So the 0 index letter is E. The one at 1 is A. Then at 2 is T. And then at, see how I'm going? So like the first letter is 0 index. The second letter is the first one. Then 2, then 3, then 4, then 5, then 6, etc., etc. If you'd like to find out the index of a certain letter or a certain character. So let's do index of in parentheses. And as you can see, it's int string.index of char value. So let's say A. I'm going to put A as a char. Remember, char is with single quotes. All right, let's put in the word bat. Okay, B is at 0, A is at 1, T is at 2. So if I run this, it says 1. That means that the letter A, the first instance of the letter A in this word, is at the first index. So notice that A is the second letter. So if B is at the 0 index, then A is at the first index, 1. So index of tells you the index of where the first occurrence is. Notice, however, if there's multiple A's, so let's go back to aardvark. Okay, so there's 3 A's in aardvark. If I run this, it gives me 0. Okay, once it finds the first one, it stops. Okay, index of A. I gave the word aardvark. And that aardvark as clearly has multiple A's. But index of just basically says like, hey, I found the first one and told you its index, and then I'm done. It doesn't even check the rest of the word. Okay, so that's what index of does. It finds which index of a certain letter in your string. Okay, remember, indexes start off with 0, not 1. Human beings start off lists with 1. C# and many other computer programming languages start off with 0. Okay, so we learned a lot. So now we've learned index of. We've also learned length to tell us how long a string is. All right, we've also learned replace. All right, so now we're good to learn substring, which is probably the hardest of them. Okay, this one gives people the chills. Substring allows you to basically get a slice of a word. So for example, you can say which index you'd like to start at and which you'd like to end at. Right? So what I'm telling the computer is take the user input, start at the index 0, which is the first letter of the string, and give me everything up until index 4. And then everything after that, cut off. So I'm going to put in a huge word here so you can kind of see how this works. Once you see it run, you'll get it. Supercalifragilisticexpialidocious. Okay, it's a huge word. Right? Substring 0 to 4. What do you think is going to come out when I hit enter? It's going to take this big word and show me everything beginning at 0 and ending at 4. It gives me SUPE. S is 0, U is 1, P is 2, E is 3. Okay, gave you everything up until 4. Okay, so if I want to like get the word super out of this, let's say I adjust this a little bit, I could do it like this. Go up to the 5th one. Supercalifragilisticexpialidocious. Right, and then I just got 0 to 5. Okay, S is 0, U is 1, P is 2, E is 3, R is 4. Okay, got everything up to but not including 5. You don't even have to necessarily start at 0. You could start, like 2 and go up to 7. So let's see what happens when we do that. Okay, I could put anti-disestablishmentarianism. All right, and then we'll start at the second index, okay, 0, 1, 2, that's T. And it goes all the way up to the 6th index, but not including the 7th. Right, so this is a kind of a cool way to take large words and cut them up into smaller pieces. Okay, substring. All right, so far we've been working with single pieces of data. What I mean by that is we've been working with strings and integers and doubles, and those sorts of things are great for one single piece of data. So for example, you might have someone's full name, right? And that is a single string, and then it says the person's name, which is fine. It's great. The thing is, sometimes we may want to have multiple people's names, right? That's more realistic, right? So like, for example, if we're running a report on our customer base, well, it's going to be more than one customer, right? So there's going to be more than one person with, more than one name. A string is great. It is a single point of data, but when we have multiple points of data, we will need what's called a collection. Okay, a collection, okay, is what it sounds like, a grouping of data. Okay, you take data, like single points of data, like names or ages or what have you, and you collect them. You put them all together into a bundle. And there's different ways to do that in C#. It is a thing that you have to do pretty much in every programming language, is to be able to bundle data so you can work with it as a group. The first way we're going to learn in C# is an array. Right? Now, an array is essentially, you could think of it sort of like cubby holes, right? So like in the old style libraries, they had like, or in like classrooms, they had cubby holes, and there was like one for each student. So you can think of it kind of like that. It's like little slots where we can put data in. To indicate that something is an array, we're going to use square brackets. So let's say we had an array of integers. So an array has to be of a certain type. What I mean by that is the data you put in the array has to be of the same variety. So if you have an array of strings, everything inside must be a string. If you have an array of integers, everything inside must be an integer. So let's do an integer array first. I'm going to type int, because it's integer, and I'm going to put square brackets here to indicate it's an array. So with computers, typically these square brackets indicate that something is an array. All right, and then we're going to give it a name. So remember, this is the type of data that we're working with, and then we label the data we're working with this name. You can name whatever you want. I'm going to call it IntArray. And you can see IntelliSense is already helping me a little bit. Okay, we're going to do new, int, and then brackets. Now, you might be wondering about these brackets. Why is it red? What does this mean? An array has a set size. It has a certain number of elements you can put into it. You decide that when you create the array. So for example, if we want an array to hold 10 people's names, the size of the array needs to be 10. Okay, that means it holds 10 things. Okay, so you need to know in the beginning how many things you want to store in this array, because arrays cannot change size. So let's do an array of 5. Okay, there's 5 things in this array. Now if you want to start off the array with certain values, if I do it just like this, the array is blank. Essentially, it's like a blank cubbyhole. Like you have 5 slots that can hold integers, right? But there's nothing in those slots, right? So let's put something in those slots. After the brackets, I'm going to put square brackets here, curly braces, and then I'm going to put 5 integers separated by commas. So they can be any integer you want. So 65, 10, 2, 4,256, and 42. Right? Notice how the red went away as soon as I put the 42 in there. Okay, look, a couple small details. Because we said this is an integer array of size 5, that's what this portion here means. It means that there must be 5 elements in the array. Element is a fancy way of saying like part of the array, like what values are in the array. So notice I have 65, 10, 2, 4,256, and 42. Each of these individual things is an element. If you remember from strings, we talked about like string.length and index. Well, arrays have indexes. Arrays, basically the index tells us which numbered slot is it. So it starts off at 0 because C# is a 0 index language, so everything starts off with 0. Human beings are 1 index, meaning they start things off with 1. Like when you make a grocery store list, you don't start off the first thing as 0, you say like the first thing on your list is 1. But computers, they made it 0. You can probably go research why that is, but let's keep in mind that's the way things are. So 65 is at the 0 index, 10 is at 1, 2 is at 3, 4,256 is at 4, 42 is at 5. Okay, so 0, 1, 2, 3, I'm sorry, 4. Okay, so 0, 1, 2, 3, 4. So it starts off at 0. All right, this is our first array. And you can see that arrays are convenient for when we have more than one integer. So like a regular integer, like if I just did like int some number equals 65, that's cool, but I can't include other pieces of data with this in one bundle. An integer is just a single point of data. These could be, for example, maybe like if let's play around with these numbers a little bit, make something realistic, 75, 62, then we'll do 70, and then we'll do like, I don't know, 76, right? Maybe these are temperatures. Okay, maybe this is like a weekly forecast, and there's temperatures in the week. Well, we could say maybe like Monday is the first one, Tuesday is the second one, etc. Right? And they could be like daily temperatures during the week. Okay, that's a set of data. That's why we have collections, because we can bundle the data up together. It's a lot more convenient. Now you may be wondering, how do I actually like draw out some of these values? Well, we use those indexes I was talking about. So what I'm going to do is I'm going to do, let's do int Monday temperature is equal to, now here's how you actually grab the data out of there. The name of the variable is IntArray, right? That's what we labeled it. Okay, this is an array of integers. So you take the name of the variable, IntArray, you put brackets next to it, and then the index of what you're looking for. So this is the 0th index. This is 65. So that means Monday temperature will be set to 65. I'm going to console.writeLine and then Monday temperature. All right, and then you'll notice when I run it, it will say 65 in the console. Okay, bam, 65. All right, so to compare, all right, so we declared an array of integers. We said that there had to be 5 elements in this array, so we gave it 5 elements. Then we said, okay, cool. I made a variable called Monday temperature, and then I set that equal to the first element of the int array, which is at index 0. So I use square brackets and put a number inside the square brackets. And then as you can see, when I write out Monday temperature, it gives me 65, which is the 0 index one. So if I change it, let's say I have like int Wednesday temperature is equal to int array, and that would be at index 2, because we'll do Monday, Tuesday, Wednesday. That'll be the second index, 0, 1, 2. Right, now console.writeLine Wednesday temperature, love IntelliSense. And there we go, it prints out 63. Monday temperature is 65, Wednesday temperature is 63. Okay, a couple small details about an int array. Once you declare the size of the array, you can't change it. So that means that this array can hold 5 elements. No more, no less. Okay, that is it. If you want it smaller, you need to make a new array. If you want it bigger or smaller, you can't just change the array willy-nilly. That's what you set it at. So it's kind of an inflexible collection. It doesn't allow us to change things. So if I do like int array, right, if we look at some of the methods, like you're not gonna be able to like add things to it. All right, you can get the length like string. So for example, I can do console.writeLine, and then I can do int array .length, and that will tell me how many elements are in the array. So I'll put a little string in front, so number of elements in array, and then I'll run it. We'll see what we get. Number of elements in array, 5. So the length, just like string, will tell us how many elements are in the array. If you like to change the value of an element, so for example, let's say I want to change 65 to 67, right? So what you can do is you can basically say int array, then the square brackets, and then the index is equal to 67. Now I'm going to console.writeLine, and I'm going to do int array 0. Bracket 0. Okay, initially it's 65, but then you'll see that it changed. Okay, so initially it was 65, but now it's 67 because I've changed it. Okay, and the way you do that is, again, you just have the variable, square brackets, the index you would like to reset, and then say equal to whatever new value you want. Okay, that's how you work with arrays. All right, so now we've got the basics of arrays. You can do this with integers, you can do this with strings, you can do this with pretty much what you want to do with it. So like, for example, if you want an array of people's names, you could do string, and then do the brackets, do like name array equals new string, brackets, and then let's say there's like 2 people, then squiggly braces, and you can put their names like Jack Smith and John Smith. Right, and there you go. You got an array of strings. So booleans, integers, doubles, floats. Okay, we have an array pretty much of what we want. All right, let's work with arrays and looping through them. So I've got this array of strings, which represents a list of students. All right, so we got 4 students, not a huge array. Let's try loop through it. So we're going to use a for loop. All right, now, because we're using the index of I is keeping our place in the loop, we can use this to our advantage. Notice how IntelliSense is already helping me. So int I equals 0, I is less than students.length. Remember, length is a property of arrays. The length is how many elements are there in the array. So in this case there's 4, so length will be 4. And then at the end we do I++. Right, and this is our basic for loop. Right, again, so if you forget for loops, please go back to the video about or the section about for loops and review. But this is our placeholder. This is the condition where we want the loop to continue. This is what we do at the end of the loop. This is the part that gets most beginners, like, they don't really get this. Think of it this way. Our array could be like 10 things. It could be 15 things. It could be 100 things. I'm using students, not length. You know, so some people might ask, like, why don't we just use 4, right? If we want to loop through this thing 4 times, why don't we just use 4? This is more flexible because when I do array.length, whatever the size of the array is, this will get it. So what I want to do is I want to loop through every single element in the array. So if you think about it, right, we start off with 0, which is our first element. Then it will go up to 1, then 2, then 3. Okay, so you see how it lines up with the position of each element, the index of each element. Then when I becomes 4, the loop will stop. So it'll go 0, 1, 2, 3, and then stop. Okay, this is how we loop through an array like this with a for loop. So now inside I can do what I want to do. Like I can just like console.writeLine students bracket I to show the value at that point. So let's see what happens when we run this. Okay, Bob Jones, Lisa Smith, Kate Acker, and Kyle Stone. All right, so you see what it did. On the first loop, I was 0. 0 is less than 4. Students.length would be 4, right? Because there's 4 things inside this array. And so it wrote out this part, students, the students array, the 0th element. Remember, I is always changing. I is going to go from 0 to 1 to 2 to 3. So when I is 0, we get Bob Jones. When I is 1, we get Lisa Smith, then Kate Acker, then Kyle Stone. So you see how, like, as I changes, it's very convenient because it lines up with the index of each element in the array. Now, if you don't like this, like this is sometimes hard for beginners to understand. There is another way you can handle this. It is called a for each loop. Okay, we're going to do for each. Okay, instead of doing for. Now what we can do is we still need a placeholder variable, but it needs to match the same type as the array. What I mean by that is this is an array of strings. Okay, so that means that our placeholder variable also needs to be a string. And you can see IntelliSense already knows what I want. So string, let's call it student. Again, you can call it potato. And then we're going to use the in keyword and then the name of the array. Let's break this down. This is a variable I made up, string student. I could have just as well said potato. Okay, nothing magical about it, it's just a variable. This is my placeholder. This is going to basically be each string as I go through this array. And then you use the in keyword and then the array that you are looping through. So this is a for each loop versus a for loop. All right, in the for each loop, it could be a little bit nicer because some people don't like this bracket notation like students bracket I. Instead, each student will just be the string student. So if I console.writeLine student, okay, and I'm just going to go ahead and comment this out. You'll see it gives me exactly the same output. Okay, you see how it goes through each name in the list, right? So for each, it goes to the first element, which is Bob Jones, prints it out. So this variable student on the first go around is equal to Bob Jones. Then the computer gets to line 11, then comes back up to line 8. Then says, okay, cool. Now the variable student is equal to Lisa Smith. Prints out Lisa Smith, gets to line 11. Comes back up to line 8. Now the variable student is equal to Kate Acker. So basically, what's happening behind the scenes is that every loop, it's resetting the value of the variable student to whatever it's at. And for each will automatically end when it gets to the end of the array. It'll just stop. All right, so some people prefer this. This is actually very convenient a lot of times to use a for each loop because that way you can have the string. But if you don't, the classic way is just to loop through each individual item like this using the index in the array. Both are perfectly fine. All right, so sometimes arrays don't cut it. So arrays are great. We are able to take singular pieces of data and put them into a collection so that we can deal with them as a group, and that's great. The thing with arrays, though, is they're not very flexible. One of the things with arrays is that once we say that, like, for example, there's 2 elements in an array, well, then there's 2 elements in that array. We really can't do much in terms of very cleanly adding stuff to it. So like, let's say, for example, that this was like, I don't know, students, and I wanted to add a new student. Well, I could change the students that are already in here, but that doesn't make sense. I want to add a student. I don't want to change something that's already here. I can't, for example, then go like, for example, as students, I can go student 0 equals, I don't know, Grace Jones, right? But that changes Bob Jones to Grace Jones. So what I want to do is do like this, like students, like for example, like 2 equals Grace Jones. Let's see if that actually works, right? This is 0, this is 1. What happens if I say, okay, cool, the second element, element index 2 for students, I'll get an exception. Index out of range exception. Index was outside the bounds of the array. So there is no index 2 inside the student's array. There's an index 0 and there is an index 1, but there does not exist an index 2. And I cannot just ad hoc make up one. Okay, I declared that the array was size 2, and that's therefore it. Like, I don't have a choice. If I try to add something, like basically say like, hey, students at index 2 is Grace Jones, I'm going to get this exception. My program's going to crash, and things are not going to be great. So, since that's the case, I need something a little more flexible than an array if I'm going to have, let's say, a student management system. Let's say you work for a university. Well, there's new students every year, right? Like some graduate, so they leave, and some new students come in for freshman year. It's it's in a state of flux. You're gonna have new students coming in and students leaving and all sorts of stuff. So an array is not going to be a great choice to model that data. So this is partly the reason why we're learning so much about these different data types like strings and booleans and arrays, is because when you write a computer program, you have to pick a data type that best matches the situation you're working with in real life. Because in real life, we need to have, the computer only understands data. So we need to tell the computer about real life situations, but in terms of data. And that is like that is a whole subject in of itself. But let's say we had some sort of student management system, and then we had to add students and get rid of students as time went on. So the array is not going to cut it. This is not, we don't even know necessarily like how many students we're going to have like off the bat. Like some students might sign up for the school and then drop, and this is just, there's too much chaos for something as strict as an array to be good for our situation. But we do have something. So I'm going to get rid of all this, and we're going to use what's called a list. Okay, I'm going to write list, and then I'm going to do angle brackets. All right, these are called angle brackets. And then inside the angle bracket, I'm going to say this is a list of string. And then I can name it, since it's a variable, so it's students. I'm going to say equals new list string. So let's go over this syntax, because we have this new keyword keeps coming up over and over again. So of course we have the type. What kind of data is this? This data is a list of string. Okay, what did I name this data? Students. Again, you can call it potato or aardvark, whatever you feel like. Equals new list of string. Okay, so I'm basically creating a blank list. You can think of it like a blank piece of paper, like one of those like stencil notepad things that you write like a grocery list down on. You can think of it like that, but it's blank. Now, this list is very similar to an array in that this list can hold multiple things. Like think of a grocery list. On your grocery list are all the items you want to buy when you go to the grocery store. So hopefully there's going to be more than one, typically. So this list, however, can be resized dynamically. In English, what that means is we could add things and remove things from this list willy-nilly. Like that's what it's made for. It is made for you to just add things or remove things from it however you feel like. So for example, we can do students.add, and then we can do, let's say, Grace Jones. And then students.add Bob Jones, and students.add Emily Jones, right? So like obviously the Joneses, or like say they're all siblings or whatever. So now I've just added those to the list, and I'm going to do console.writeLine students, and let's run this and see what happens. All right? If you try to just console writeline the list, you're going to get this weird looking thing. This is the list object. You don't have to totally understand what this is, all right? But you won't be able to, I did this so that you would know you won't be able to just see everything in it. So we're going to have to do a little like for loop in order for us to figure out what's in here. So let's go do a for each loop, because a for each loop I think works really well with lists, and we just learned it. So for each, we're going to do string, because it's a string, student in students. See how it's like very similar to the array? Like this is written exactly the same way as it was in the array section. And we're going to console.writeLine student. All right, and let's see what happens. Bam, Grace Jones, Bob Jones, Emily Jones. Now the cool thing with lists is that we can add them willy-nilly, like I said before. I could add Will Smith, and I can add students.add Jada Pinkett. I have no idea how to spell her last name. Right? Say I run this. There they are. Okay, they are along with everybody else. So this list, I can add things to it. I could not do that with an array. With an array, I need to know exactly how many elements are going to be in the array. For a list, just add them, like however you need them. Now, lists also have a length. So, for example, I can console.writeLine. I'm going to do the number of students in our list is, and then plus students dot length. Okay, count, excuse me, count. With list, it's count. All right, so let's run this. Right, and then the number of students in our list is 5. All right, so one difference between arrays and lists is that it's called count. So count will give you the number of elements in the list. So that part's the same. You can use a for each loop to loop through your list, and you can add things. You can also remove them. All right. So for example, we could do students.remove, and then we'll do, let's say, Bob Jones. All right. So we added him on line 4, but then we remove him on line 11. Let's see what happens. Okay. Notice how he does not appear when we do the for each loop, right? Because he's been removed. Right, so again, this is not something you could normally do in a regular array. We can't just remove things from the array. If we say that it has 5 elements and it has 5 elements, now one of those elements can be blank, but it's still there. In this case, I've literally just taken Bob Jones from the list and removed it. So these lists are very dynamic, and they're very extreme. You will use them so much during your tenure as a C# programmer. Now, keep in mind about this part. Let's talk about this angle bracket section. This is called a generic. And what this means is that you can put whatever type in here you'd like. So we don't have to just do a list of string. We can do a list of integers. Okay, so integer list equals new list integer. If that's what we wanted to do. You could do a list of Boolean. Okay, Boolean list. New list bool. Okay, notice I have the parentheses afterwards. So this inside here is called generic. We can put in whatever type we can want, like int, bool, double. And then when you guys start making your own classes, you can even put your classes and things like that in here. So this is really, really versatile is the way I would put it. So maybe you need a list of strings for students. Maybe you need a list of integers for temperatures. Maybe you need a list of Boolean for like voting or something. Like, yes or no, up or down votes. Like, you can do that, right? The list is very flexible and allows us to do pretty much put whatever we want in there. Now, if you declare something as a list of string, though, then everything in it must be a string. So, for example, my list students is a list of string. I cannot do students.add 50, for example. Okay, I'm going to get a compiler error, this red squiggly line right here. If I hover over it, it will say cannot convert from int to string. So if you just say that it's a list of string, then every element in this list must also be a string. And if it is not a string, C# will yell at you. Okay. The cool thing is that C# is a compiler error, so you will not be able to run your program until you fix it, and then usually C# will tell you what the problem is, so I wouldn't sweat too much. But the whole point of this generic is you're saying, like, this is a list of a certain type. So this is a list of strings. This is a list of integers. This is a list of Booleans. It can't have anything else in there besides the type that you say, which is fine. Like, that actually keeps things nice and orderly and neat. Alright, so now we know about lists and arrays, and that's really good. Like, they're very useful ways of structuring data. But for some other examples, we may need to use other data structures or collections so that we can store data in a different way that's more convenient for us. Let's say we had like a dictionary. So think about like a real-world Webster's dictionary. How does it work? You want to look up a word. Well, all the words are in alphabetical order, and then you find the word, and then once you found the word, there is a definition attached to it. Yes, there could be more than one definition. That is perfectly reasonable, but let's just simplify a little bit. Just say you look up a word, then you see the definition attached to it, right? So the dictionary is great if you know the word, or at least know how to spell the word, and then you just want to go look up the meaning of the word. If you know the meaning of the word, but you don't know the word itself, the dictionary is not very helpful. So if you're trying to look up words by their definition is very hard, because the way the dictionary is set up is you're supposed to look at all of the words, and know their spelling, and then once you know the word that you're looking for, then you can look up the definition. Okay, similar to a phone book, right? You look up the name and you get the phone number. If you start off with the phone number, it can be a little harder, very hard, because you have to basically go through the whole phone book. But if you know the name, you can at least zero in on the name and then find the phone number attached to that name. So C# has a very similar idea. Basically, it's like a lookup. Okay, so we have what's called dictionaries. Okay, a dictionary has two parts, a key and a value. If you think about the dictionary, the real world Webster's dictionary example, the key is the word you're looking up, and the value is a definition attached to that word. All right, so you'll have a key and a value. Dictionaries are pretty easy to set up. We're going to make one right now. So we'll do dictionary and angle brackets, and inside the angle brackets we're going to have two things. With list we had one. We had list, angle brackets, string or integer or boolean. In dictionaries we're going to have two things. The first one's going to be what type of data is the key. Okay, so remember, the key is like a dictionary. You're looking up a word. The word you're looking up is the key. Then we're going to have another type for the value, which is the definition of the word. Once you look up the word anti-disestablishmentarianism, then you can look up and you can see the definition that goes along with that word. That definition is the value. All right, let's make a dictionary of strings. So I'm going to dictionary and string, comma, string. All right, remember, the key comes first, the value comes second. So what I'm saying is that all the keys in my dictionary are going to be strings, and all the values will be strings. You can make this what you want. You can mix and match. You can be string integer, double integer, double. Like you can literally do what you want to do in here. You can make a dictionary using whatever type you want. Let's just do strings to make it easy. All right, we'll call this dictionary lookup, because that's what we want to call it. And you can see IntelliSense is already telling me what to do. We're going to do equals, and this new keyword keeps coming up, doesn't it? New dictionary, string, comma, string. All right, we've got a blank dictionary. There's nothing in it, but it is ready for us to add entries into it. All right, let's go over a couple things about dictionaries. Number one, the key must be unique. Okay, the key, that first part, that thing that we're looking up must be unique. Okay, there cannot be two of the same key in the dictionary. All right, also, we already decided the type, so the key must be a string, and then for the value must also be a string. So how do we actually add things to our dictionary? You'll notice that it's very similar to lists. So we're going to do dictionary lookup, that's the name of the variable, dot, and as you can see, these purple cubes are all the different methods that are related to dictionaries. These methods come up a lot. It's pre-built functionality, so I say let's make use of it. I'm going to add, and then do parentheses, and then inside, if you hover over the word add, you'll see what it takes, a string key, string value. Notice how it matches the values that we set here. If I change this, I'm just doing this for demonstration purposes. If I change the key to an integer, for example, if I go back to add, notice how it changed. Now it says int key string value, right? That's why I was saying that the type has to match. And let's set it back to string. All right, so now all we have to do is just basically have two arguments. We're going to put our key and then our value. So we'll put, I don't know, unicorn, comma, and then the value will be a horned mythical animal. All right, and there we go. That's how we've added our first entry to our dictionary. If someone looks up the word unicorn, they're going to get a horned mythical animal. So how do we actually work with this? How do we actually do anything with this dictionary now that we've added stuff to it? Well, we can do dictionary lookup, and then we can use bracket notation. So for example, I can do bracket unicorn. Okay, inside the bracket is the key. Now you notice it has a red mark here, right? So it's what do you want me to actually do with this? Okay, so what happens if this doesn't exist? We'll get into that in a second, but essentially you can use bracket notation. So you can basically use this to get the value from it. So let's do. I think the simplest thing to do would just be to console.writeLine, then we'll do parentheses. Okay. And then what this does is says, okay, go to the dictionary, find the key unicorn, and then give us what the value is. Remember, this is the key, this is the value. All right, let's run this. Okay, a horned mythical animal. All right, so I went to the dictionary, I looked up the word unicorn, I got this for the definition, right, for the value. And we can add more stuff to it. Let's do dictionary lookup dot add truck a motorized vehicle that holds things. I don't know. I have no idea what the Webster's Dictionary says for truck, but we can go ahead and do that. So I can console.writeLine dictionary lookup dot, that's dot brackets, and then string truck, and I'll run it. Okay, and you can see that when we do this syntax here, with this bracket syntax, that inside is the key and out comes the value that's associated with that key. Notice how unicorn is matched up with this. This is why dictionaries are useful, is because we're matching up the key to the value. Now, let's see if we can add the same key. Let's add unicorn, and appears in many different mythologies around the world. Okay, let's see if C# will let us do this. All right, so I added the unicorn entry on line 3. I'm adding it again on line 5. Let's see what C# does. All right, we have an exception. All right, an item with the same key has already been added, key unicorn. So this goes back to what I was telling you about rules for dictionaries. In a dictionary, each key is unique. Okay, if you have a key that's called unicorn, there cannot be another key called unicorn. There is only one key called unicorn. That's it. If you try to add a duplicate key, you will get an exception just like this, and your code will not compile and not run. Do not pass go, do not collect $200. Right, so that's a rule. Right, so we're not able to do this. Okay, that's fine. All right, so if we wanted to change the value associated with the key, we can do that. So we can do dictionary lookup. It's very similar to arrays. Unicorn equals appears in many world cultures. Okay, and I'm going to go ahead and do a double console write line. I'm going to comment out line 8. Right, and then we're going to run it again. All right, now notice that on line 7, output this line, but line 12, output this line. All right, so that means that we basically changed the value associated with the key unicorn. Right, so you can change the value of a key, you just cannot add a duplicate key. All right, so dictionaries are great for lookups. Okay, when you want to look up something, when you want to pair things together, okay, you want to pair like a word with its definition. Okay, maybe you want to like pair a customer, I don't know, with their order. There's lots of different ways you could use a dictionary. It's not as widely used as lists are. Lists are probably the #1 thing to use. They're just so versatile. But dictionaries are really good to know, and we'll get more into what we can do with them. But this is a good introduction to how we use them. All right, I've added some handy-dandy SAT words, like adumbrate, I think is how it's pronounced, abstruse, rococo, and abnegation. You know, words, everyday words that people totally use in their everyday life. That's not just for the SAT. So here are the keys. The keys are on the left, and then the values that go with each key is on the right. And so now let's learn how to iterate through a dictionary. That means loop through all the keys in the dictionary. One thing I want to make clear is that the keys in the dictionary are not ordered in any way, like they're not alphabetically ordered. That's one common mistake that beginners make. They assume that like the keys have some sort of order to them. They don't. It doesn't sort them for you. There is such a thing as a sorted dictionary. That's a completely different thing though. With a dictionary, it just depends on what order we put the keys in. All right, so we're going to use a for each loop. For each loops are way better when, with dictionaries. And if you notice, IntelliSense is already telling me what to do. So the type that we're going to use is key value pair. All right, so key value pair basically means these two things together. All right, so you're going to get a key value pair. You'll have access to the key. You have access to the value in one package. So the key is a string, and then the value is a string. And then I'm just going to call it KVP. That's just the name I'm going to give it. In dictionary lookup. So we have that for each in. Okay, that in keyword here. Now, once we do this, we have access to the key and the value. So I'm going to console.writeLine kvp.key. All right, so let's make it a little clearer. I'll put the key is colon plus. And then what I will do is console.writeLine the value is plus kvp.value. All right, so Key value pair has the key and the value. It is like bundled up together so that it's nice and easy to use. If I were to run this and wait for it to compile, all right, so as you can see, the key is adumbrate, or however that's pronounced. The value is describe roughly or give the main points or summary of. So you see how there's the key here and then the value that goes with it, right? And we were able to do that by looping through it. So if we go through and compare this to our loop, okay, you can kind of see what the computer is doing, right? So this key value pair part is the part I would kind of remember, because that is how you're going to get the information out of the dictionary as you loop through it. Again, the for each loop with dictionaries is way easier than trying it with just a regular for loop. So I would just go ahead and do this. It's way easier. So again, you do key value pair and then string and string, because the dictionary is both string, the key is a string, and the value is a string. Then you give it a name. I just called it KVP because I felt like it. You can name it potato, in, and then the dictionary itself. And then once you're inside the for loop, you can do kvp.key or kvp.value. You don't have to use both. You can, if you want to use the key, use the key. If you want to use the value, use the value. But this would be an example of looping through a dictionary, all the keys in the dictionary. All right, so as we know, the user is not always going to do things the way we want them to do it. And sometimes the user can put some information in, and if our program is not ready to handle it, then we could get errors. We kind of saw this with the guessing game, right? The user could possibly, for example, just not type anything in and hit enter. Well, we've got a little calculator app here. It's not the world's greatest calculator. We're still working on it. It can do division, right? It cannot do addition, subtraction, or multiplication, but it can do division. Our R&D department will work steadily through the night to get the other three arithmetic operations, but division we've got down pat. Now, we asked the user to give us a numerator and a denominator. So if you don't remember what those mean, numerator is the top number, denominator is the bottom number. You divide the numerator by the denominator, and then you get a quotient, which is basically like the number you get after you divide something. So 10 divided by 5 will give us 2, for example. 10 would be the numerator, 5 would be the denominator, and the quotient would be 2. All right, so on line 4, they type in a numerator. On line 6, they type in the denominator. And then on line 9, I take the numerator and turn to an integer. And then I take the denominator and turn to an integer. And then I divide them, the numerator by the denominator. And then I write out the quotient, whatever they divided. So leaving aside whether or not they can put blank spaces or numbers, we're going to assume that they're going to put in a number, right? So the in.parse will work. All right, and so let's just leave it at that for right now. Let's see what happens just on the first run through. All right, let's say I pick 10, then I pick 5, divide the two numbers, it gives you 2. All right, so our R&D department is very happy. Our first focus groups came back with rave reviews about our calculator app. The problem is it has a possible bug in it, in that we could ask the computer to do something impossible. So for example, let's say someone comes in and says, okay, cool, I want to have 25 divided by 0. We have an exception. In fact, it's this exception called divide by 0 exception. We've seen these exceptions before, and they're very important in terms of computer programming. Because again, an exception is when we ask the computer to do something impossible. And the computer's like, listen, you commanded me to do something, but I literally cannot do it, so I'm going to throw an exception. The verb that we use for exceptions is throw. I'm going to throw an exception and let you know that, like, hey, I can't do what you're asking me to do. So there's different kinds of exceptions. Usually the name of the exception will tell you what's wrong. So for example, in this one, it's called system.divide by 0 exception. I mean, that's pretty straightforward, attempted to divide by 0. So the computer's like, listen, nobody can divide by 0. Like, don't ask me to do that for you. So what happens with an exception is that once that exception is thrown, the program stops. Okay, like our program has crashed. We did not get to line 11. Okay, any code we had after line 9, if there's an exception, will not be run. So the program will crash, and the user will just be sitting there going like, well, what the heck happened? Like, what was I supposed to do? So we don't want to have this sort of thing happen in our program. Now, looking at it, if you just do the program with the happy case meaning like the user does exactly what we expect them to do, you're going to walk along thinking that all your programs are great and that they'll work out in the real world. But the thing in the real world is we have You know, people will put 0 for the denominator. They'll put blank spaces. They'll, if you ask them how old they are, they'll put cat. Like, all sorts of weird, zany things that don't make any sense could be data that comes in, and our program has to be flexible enough to handle it. Well, this is fine. We have a way of actually dealing with this. So it's called try catch. So above line 9, I'm going to put what's called try, and then I'm going to put squiggly brackets, and then I'm going to write the word catch, parentheses, and the type of exception I'm expecting. If you don't know what kind of exception you expect to get from your code, you can just leave it as exception. All right, so it looks like this like dark green color. Okay, this is exception is like the general exception, any kind of exception. But notice that we had specifically a divide by 0 exception. So it's better to be more specific with what exception you expect to get back. So I'm going to put divide by 0 exception. Notice that this is the type, and then this is the variable. This is no different than string numerator, int, people, blah, blah, blah. This is a type. Divide by 0 exception is a type. And then we have the variable, we call it ex. I could call it aardvark for all I care. And you're thinking to yourself, what on earth does this do? Try, the try block, meaning beginning these curly braces, everything between these two curly braces is the try block. You put in code in the try block where there's a possibility that it could throw an exception. Okay? There's a possibility that the person could type 0 and throw an exception. Okay, there's no guarantee that they won't. Okay, there's like stopping them. All right? But the cool thing is if you put things in a try block and they throw an exception, it won't stop the program. The program will not crash. Now, you're wondering what this catch is about. This catch says, hey, if this exception gets thrown, okay, if this comes up, I would like for you to run what's inside the catch block. That means between line 14 and 16. So for example, we could write the person a nice little message saying like, sorry. So for example, say like, sorry, you cannot divide by 0. Right? Just let the person kind of know. So let's go over this again. The try block is for any code that you think might fail. Okay, where it could possibly throw an exception. It doesn't mean it will throw an exception. It's just a possibility, right? What it does is that if this code does throw an exception, instead of the app crashing, it's going to go ahead and go to the catch block, right? So it'll go to the catch block and be like, okay, cool. Instead of crashing, I'm just going to go to line 13 through 16 and run the code that's in here. Now notice at line 19, this quotient is now red. That's because if I declare a variable inside my try block, that means it can't be used outside the try block. So it only can be used between these two squiggly brackets. Since it's out here, what I'm going to do is I'm going to move this line up here. Now it's back to being normal. So you can think of it like this. I'm going to try this code out. If all goes well, then everything in here should run, and then everything should be fine. If I get an exception, specifically a divide by 0 exception, then I am going to write this line instead, but my program will not crash. So for example, I'm going to put a piece of just throwaway code here saying, hey, we reached line 19, no crash. Okay, to prove to you that even if I were to divide by 0, we would still get to line 19, we would not crash. Let's give it a try. Pick a numerator, 100. Pick a denominator, 0. Sorry, you cannot divide by 0. Hey, we reached line 19, no crash. So you see how I divided by 0, it threw the exception, and then we have this like little message here saying, sorry, you cannot divide by 0. Well, I need to put the word divide in here. Now, if we do it normal, like if a person is just a normal person and decides to just put like, I don't know, like 200 divided by 10, then cool, it runs like normal, which is what we expect. All right, so this is try-catch, and try-catch is a fundamental thing you should learn. Okay, remember, sometimes code will compile. Like, I can build this, and it will compile and run, but there could be a situation where the user or some other, person using our program gives us data we can't work with or asks us to do something that's impossible. All right, so since that is the case, we need to have a try-catch to ensure that our program runs smoothly, that it doesn't crash. Okie doke. So let's say we take like a real world situation where we record temperatures daily and we would like to get the average of all the temperatures that we've recorded thus far. So I live in Michigan. We record things in Fahrenheit, and we can have wild swings in temperature. It could be snowing one day, and then in the afternoon it could be sunny and warm. It's whatever it feels like. So I've got some temperatures that were recorded. All right, we like to get their average. Right, so they're a list of double, and what we could do is we could write a loop, go through each number, and sum up all the numbers together. Right, add them all together, and then divide by the total number of numbers that there are. Right, that's how an average is, when you sum everything up and divide by the total number of things that there are. So I'm going to make a placeholder int temperature sum is equal to 0. I'm going to use a for each loop. For each, and literally IntelliSense does it for me. Each temperature reading is going to be a double in weekly temperature readings. Remember, weekly temperature readings is this list. Then all I have to do is temperature sum plus equals temperature. And what this does is it just adds them together, right? So plus equals temperature. So this needs to be a double. You have to add the match. All right, so the first iteration, 85 plus 0 will be 85. The second iteration, it will add 87, which is like, what, 172, and then et cetera, et cetera, et cetera, right? So it'll keep adding each number on to temperature sum, and at the end, temperature sum will be the sum of all the numbers that are in the list. Then to get the average temperature, all I have to do is just basically take temperature sum and divide it by the total number of readings that there are, which is count. Remember, lists have a property called count, which tells you how many elements are in the list, right? It will count it up for me. Then at the very end, I will console.writeLine and say the average, I'll put a $sign here first actually, and the average temperature is, and then put average temperature. Okay, and we'll run our app and we'll see how it works. The average temperature is 81.18181818, etc., etc. All right, cool. And this is pretty flexible. If I add some more numbers in here, like, I don't know, 65, 85, because I wrote it in such a general way, I'm using like weekly temperature readings.count. So if I add more here, it'll just sum up whatever numbers I add and divide them by the total count, and I'll get a new average. So here we go, 80.23. Okay, that's cool and all, but what if I told you we don't have to write all this stuff? Like, lines 6 through 13 can be summed up in a single line. This is where LINQ comes in, LINQ. This is a library that comes with C#. You did not have to do anything special to get it. You get it for free. LINQ is a library that's all about working with collections, okay, lists and dictionaries and all that good stuff. All right, so since that is the case, I can write this code way more succinct than using a for each loop. There is nothing wrong with using a for loop. I want you to repeat this to yourself. There is nothing wrong with using a for loop. The only thing is that sometimes you could write the same logic in like one line. I could do that with this. I'm going to just go crazy and get rid of all this code. All right, done, gone. I'm going to do double average temperature is equal to weekly temperature readings dot average. That's it. All that code we just wrote could be summed up in a single line. So I'm going to run it. There we go. So instead of writing all that logic with a for loop, I could just use this average. This is part of LINQ. If you hover over average, it will tell you more about it. It returns a double, and it works on this IE enumerable. You could think of it as like a collection. Okay, it's the simplest way to think about it. And takes the average of a sequence of double values. Cool. All that extra stuff I did not have to do. There are other things we can do besides just averaging things. So for example, I could do double sum of temperatures. I had to do a for loop for this, right? So I don't need to do a for loop for that at all. I can just do sum. Okay, and it will give me the sum of all of the temperatures. It will add up all the numbers that are in this list and put them together. So we've got average, we've got sum. Maybe I would like to know the highest temperature. So like console.writeLine will say the highest temperature was, all right, well, what was the highest temperature? We'll do double highest temperature equals weekly temperature readings dot max. And then opposite would be lowest temperature equals weekly temperature readings dot min. So now I can say the highest temperature was we'll do squiggly braces, highest temperature, and then for the other one, we'll do lowest temperature, console.writeLine. The lowest temperature was lowest temperature. All right, let's give this a try. Let's see what happens. All right, let's see what happens. The highest temperature was 92. Looks good to me. 92 is the highest number. The lowest temperature was 65. The average was 80.23. Now, again, we could write for loops, okay, that would be able to answer these questions. But instead of writing 3 or 4, 5, 6 lines of code, I find it much easier to just write one line of code and let LINQ do the math for me. Okay, so LINQ gives us these pre-built functions like average, sum, max, and min. There's more. There's way more to LINQ, but this is kind of gives you a taste of what LINQ can do. Okay, so notice that after I had a list of something like weekly temperature readings, and I hit the dot, then you'll notice that there are some of these purple blocks with like these arrows. Okay, that kind of gives you a hint as to what LINQ can do for us. So LINQ can do so many things, but I wanted to get LINQ can do so much more than just averaging and summing things. It's really a very, very powerful library to work with collections in C#. It's one of the main features of C#. It makes it a really great language to work with. So I've got a list of integers here, and they're in no particular order. They're just random. I just pick some. All right. So I'd like to pick out just the even numbers. Okay. So I want to keep the even numbers and ditch all the odd. So that's called filtering. So filtering is another feature of LINQ. So far, we've used the aggregate stuff. What I mean by aggregate means putting stuff together, like summing. Summing is aggregate, or average, putting them all together, getting the average. Getting the min and max are also things we can do with LINQ, but what if I want to filter out things? What if I want to say, like, I don't want certain things, but I want to keep others? LINQ makes that really simple too, all right? Now, let's see how we would do this normally, just with a for loop. And again, for loops are fine. So I'm going to do for each int number is equal to int number in integer list. All right, and this will loop through every number. We'll go one by one by one by one. Now, how do I check to see if the number is even? Well, there is a special function called modulo. So we're going to use the if statement. If number modulo, which is a %, 2 equals 0. What this means is, what modulo does is that if you divide, it will divide this number, the number that comes on the left side, by the number on the right side, and check the remainder. So it's not looking for the quotient of the numbers, it's looking for the remainder. Even numbers are all divisible by 2. Any even number divisible by 2 will give you a modulus of 0. So 4 divided by 2 is 2, there's no remainder, so therefore it's 0. 4 modulo 2 is 0. If it were 5 modulo 2 would give you 1, because there'd be 1 remainder. 2 goes into 5 2 times, but there's 1 left over. So if number modulo 2 equals 0, that means that the number is even. Then we're going to go console.writeLine and put the number. So let's give this a try and see what happens. And again, if you look through, we get the even numbers. We get 10, we get 16, we get 9,910, 72, 688, 72. All right, so it filtered out all the odd numbers. All right, but, and this is fine. Like, this is a perfectly legitimate way to solve the problem. We can instead condense this code into one line with LINQ. So we're going to get rid of this for each loop. Instead, I'm going to do integer list dot where. Okay, and this where is it looks very intimidating to beginners. All right, but it really isn't. Inside the where, we're going to put what's called a lambda. Okay, an arrow function. Okay. And you don't have to totally 100% understand what those do just yet. You just need to follow the pattern in the beginning, and eventually you'll get the hang of it. A lambda function is like a mini function. Okay, it's a mini method that we can put inside of here. We're going to pick a letter. We're going to call it x. It could be y. It could be potato. It's just a variable. So we're going to do x arrow equals sign with the caret x modulo 2. Oops, modulo. Equals 0. Okay, and then we're going to put to list. All right, let's break down what the heck is going on with line 6. This where is a filtering function. Okay, what where says is, hey, I'd like to filter integer list. Okay, I would like to filter integer list. Okay, what criteria do you want to use to filter it? Well, we're going to put this function in here. What we're saying is, We have x arrow x, so you do a variable, then an arrow, then x, and then here is the part that we're checking for. Basically, I want things where x modulo 2 equals 0. So it will run through all the numbers in this list and say, hey, x modulo 2, so we'll start with 1. Is 1 modulo 2 0? No, it is not. Okay, it doesn't get included in the list. Next one. Is 5 modulo 2 0? Nope, 5 modulo 2 is not 0. Go to the next one. 10 modulo 2. Is 10 modulo 2 0? Yes. So we'll keep it. So I'm going to save this in a new list. So we're going to do list of int, new even list is equal to this. Now keep in mind I have this to list at the end. You might be wondering, well, Jonathan, wasn't it already a list when we filtered it? We want to make sure that this becomes a list. If you don't have this to list at the end, it will still work. But you'll notice that it has this like red line. It will say like IE enumerable int, and it will have an argument, null exception, filter, all this cannot implicitly convert IE enumerable int to generic that list int. So if you want to make it a list, you have to have this to list at the end. IE enumerable we'll get into when we talk more about interfaces and things like that. So for right now, if you would like this to be a list, you're going to need this to list at the end. That's good enough for a beginner to understand for the moment. Now I'm just going to loop through here and show you what happens. So for each integer int, let's call it number, in even list, console.writeLine number. And you'll see that it also was able to filter out all of the odd numbers. Okay, so, which is great. Okay, we were able to do that, and we were able to do that with this where clause, all right? So, again, for each loop, no problem, you can do that, but you also can filter things out with this where, all right? So, again, let's go over this syntax because it can be a little bit daunting for a beginner. We have the list, okay, integer list, that is this variable here on line 1. Then I have this where function. It's included with list. List comes out the showroom floor with a where function. Inside the where function is an arrow function. Okay, this is a lambda. X arrow x, and again, this could be y. I could just as well call this y. I could just as well call this potato. Okay, it's whatever I want to name it. People typically pick one-letter things because it's easier to type. All right, x arrow, and then in here is what I'm looking for. I'm looking for things where x modulo 2 is equal to 0, meaning that they're even numbers. After you go through this entire list, I want you to give me a new list. Go through everything, and when you're done, I want you to give me a list. Okay, and that is what line 6 is doing. So we can use where to filter out things we don't want and only keep the things we do want. So now we can see that LINQ is really powerful. LINQ can sum up things, it can average them, it can tell you the highest and lowest, and also can filter out things that you don't want. So LINQ does a lot of really cool things for us. It could even do this for each stuff for us, which I'll show you in the next part. Alright, let's work with this where clause some more because it's very important that we get a grasp on it. So I've got this integer list and I've got a bunch of numbers, and let's say I want to get all the numbers that are above, let's say, I don't know, 100. Alright, so we just did where to figure out like whether or not something was odd or even. We can also use it with like greater than or less than, like we do with if statements. So for example, I could do, let's say, list of integers above 100 list is equal to integer list dot where. So we're going to use this where clause, and again we have to use this arrow function. So x arrow x is greater than 100. All right, dot to list. Right, so this will filter out all of the numbers that are not over 100. So I should not see any number that's 100 or less in my list. So I'm going to go for each int number in above 100 list and console.writeLine number. All right, so let's take a look at what this does. All right, notice how it filtered out all the numbers that were not above 100. So we got 525, 688, 1005. All of these match our criteria. Now the cool thing with where is that you can actually have more than one criteria, much like an if statement. So just like with if statements, we have like and or, that applies here too. So let's say I want all the numbers above 100 that are also even. All right, so I'm going to use and, two and signs, x modulo 2 equals 0. So now there's two conditions. I want the number to be above 100. I also want the number to be even. Now let's see what we get. right? Now this time we only got 9,910 and 688. So we are able with where to do multiple things. You don't have to just filter it based on one property. You can filter based on however you want. I want all numbers above 100 that are even. I want all people who are over the age of 65 and live in Florida. Okay, so like that's fine. You can do literally whatever you'd like with where. And you can have as many of these conditions as you'd like to chain them inside the where clause, and then there you go. So again, you can use and or also works. Let's say I wanted things that were above 100 or were even. Now this is different. So the number could be above 100 or the number could be even. So we're going to see what this gives us. Now notice that there are some numbers that are below 100 here, right? Well, that's because OR looks at either condition. If either condition is true, it makes it into the list. So for example, 10 is not above 100. That's true. But 10 modulo 2 is 0. Okay, 10 is an even number, so therefore it makes the cut. So you see how with OR, at least one of them needs to be true. Okay, so OR is basically looking at both of them. If either one of them is true, they can make it into the list. If both of them are true, then obviously they'll make it to the list. But and says both have to be true. That means this needs to be true and this needs to be true. All right, they both have to simultaneously be true. If either one is false, then it doesn't make the cut. All right, that's why we get a much smaller list when I put that and there. All right, well, now you know how to use where with multiple conditions. Okay, so you can really fine tune your filtering. And we can even redo this for each loop. We don't even really need this. We actually can use LINQ to do for each, and I'll show you how to do that next. So if you've noticed by now, LINQ is a library that helps us kind of avoid writing for loops, right? So because a lot of the examples I've done so far could be just as well done with a for loop, but LINQ is more compact. It's a more compact way of writing these things. So you could even do a for loop with LINQ. So again, we have this list of integers, and let's say I just wanted to like loop through and like write each one to the console. All right, so to do that, I'm going to do integer list, which is the name of the, like it's the variable, like the list of integers. And then I'm going to do for each. All right, so for each is the method. It comes from LINQ. And you'll notice that the IntelliSense is already telling me to put an arrow function in here. So we're going to do an arrow function. X, arrow, X. And so after the arrow, you can put like, what would you like to do for each one of these things? So I would like to console.writeLine X. Now you're wondering what the heck is X? Hover over it and you'll see it's an integer. Because this is a list of integers, X will represent each number as it loops through. So it will go to the first one and then X will be 1, then X will be 5, then X will be 10, etc., 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 as it loops through. So on one line, I can loop through this list of integers and write them to the console. Let's see what that looks like. Bam, there you go, 1, 5, 10, 525, etc. So instead of writing a for loop, I just did for each, and then it wrote it to the console. Now the cool thing is we can chain a lot of these methods we've been learning together. So let's take where, for instance. Let's say I wanted to write out only the odd numbers. All right, so before the for each, I'm going to do integer list.where, and then inside these parentheses, I'm going to do x arrow x modulo 2 does not equal 0, right? That's for odd numbers, all right? Then I'm going to do dot to list, then dot for each. So you're thinking to yourself, my God, Jonathan, this is a monstrosity. Like you've chained where to list and for each all together, and now it's all in one line. What the heck is going on? All right, let's break it down. So we have our original list of integers, okay, integer list, that's all these numbers here. The first thing I want to do is filter them, okay? So I'm saying using where to filter out the numbers I don't want. So I only want odd numbers. So I want all the numbers where x modulo 2 does not equal 0. So remember, the modulo is dividing by the number and then getting the remainder, okay, what's left over. So an odd number divided by 2 is going to have something left over. It's going to have a remainder. So I'm looking for x modulo 2 does not equal 0. Then take that filtered, so I'll go through here and filter all the ones that are odd and make it into a list. Then take that list and go through it like for loop, right? Go through each one and write it to the console. So let's go ahead and see what happens. As you can see, what printed to the screen? Only the odd numbers. So now instead of writing like multiple for loops and multiple variables, I can chain the different methods from LINQ to first filter all the numbers for just the odd numbers, and then go through them and write them all to the console in one line. So this is the power of LINQ. It's very concise, clean code, and I can look at it and be like, okay, cool, I know what's going on. You're filtering out the odd numbers, and then you're looping through them and writing them to the console. All right, so this will require that you understand each individual part. You'll have to learn how to use where. You'll have to learn how to use for each. But once you're more comfortable with them, you can chain them together. Now notice I had to put to list first before for each. Without the to list, it will not be. You'll have a compilation error, because what comes after the where is not a list. Okay, lists have the for each method. Okay, so you have to make sure it's a list first before you can use for each. But now you can chain things. Okay, you can have multiple where clauses. You can have for each, and then you can chain things however you'd like to chain them. That's the power of LINQ. LINQ allows us to work with data sets. Okay, more than one piece of data, and then do what we want. Do we want to get the average or the sum? Do we want to filter out students over the age of 20? Do we want to do something for each one of them? Okay, LINQ allows us to do that. All right, let's get into the nitty-gritty of object-oriented programming. Okay, object-oriented programming, or OOP for short. And C# is all about the object-oriented programming. All right, so here's the thing. Let's say that we're programming an app, right? The app is going to be used by a university to keep track of student information. So we have students, all right? And the students have all sorts of bits of data about them that we need to track. So we'll have new students coming in for the beginning of the semester. We'll have students graduate. Maybe some students drop out of school. Maybe some students come in mid-semester. I mean, it's whatever they want to do, right? So we have students doing all sorts of things. So we have all this data related to students, and we need to keep track of it somehow. Now, we could use lists. So, for example, I could do a list of string and say student first names, and then make it equals new list string, and then maybe we could have some like John, Mary, and Sue. And then we can make another list, and then do student last names equals new list string. And then in here, we'll have John Smith, Mary, I don't know, Matthews, Sue, whoever. All right. Now, we can have lists for the first names of the students, the last names of the students, the ages of the students, and we could really just go down the line. The problem with this is that this is very unwieldy. The more information we have and the more students we have, the more confusing this looks. It would be nice if we could take all the information and put it in one package, right? So for example, if we had one object or package that contained the student's first name, last name, age, and let's say student ID, and they were a convenient package that we could access, then it'd be a lot easier than trying to have a bunch of lists for the first name, the last name, the age, and we have to assume that the first name in the student first names list corresponds to the first name in the student last names list and all sorts of others. This is where classes come in. All right, so let's get rid of this stuff. Let's do something a little more efficient than this. All right, I'm going to right-click on the project. I called my project C# classes. You can call your project whatever the heck you want to call it. It does not matter. So we're going to do add class. All right, and then we are going to just call it student. Bam, we've got our own student.cs file, and inside it says namespace, C# classes, and internal class student. I don't like to have all these squiggly braces, so next to namespace you can literally put a semicolon and it'll get rid of those squiggly braces, so now it looks a little bit cleaner. I'm also going to change internal to public, okay, and we'll talk about that later. But now I've got a student class, and now I've got something where I can package everything together. So let's start with the properties of a student. All right, we're going to do public string first name squiggly braces get set. It'll just like this. All right, so what does this mean? When I have a student, I say that students are things that have first names, and the first name is a string. Okay, and we have this public, which we'll talk about in a little bit, but for the moment we just need to focus on this part, string first name. So you're just wondering, well, what does this actually do? Let's go back to program. All right, in program, I'm going to create a student. Okay, so a class is like a blueprint, like when you're building a house. So the blueprint is not the house itself. Some architect made up the blueprint, and the builders will look at the blueprint and follow the instructions to build your house. So the same thing with the class. The class itself is just a plan for how the student gets built. If we want to actually create a student, we have to instantiate a student. And instantiate a student just basically means make a copy from the blueprint. That's all it really means. And we've been instantiating things this entire time. We've been instantiating lists. We instantiated the random class. We've been using the new keyword to do it. Once you look at it, you'll notice that it's the same thing we've been doing. So we're going to create a variable that is of the type student. Student equals new student. And then we'll put parentheses. Now, the compiler is red because it doesn't know what the student is. The student.cs is a class in another file. Okay, the student.cs is a separate file. So we need to import student into program.cs, and that's pretty easy to do. Visual Studio makes that simple. I'm going to hover over student. I'll have this light bulb with a red X. Click on it. It says using C# classes. All right, typically I'm going to put my using statement all the way at the top just because I am persnickety about such things. All right, now what using means is say, hey, like, there's some code or a file or like basically a namespace somewhere else. I want you to go use that. So it says using C# classes here. Notice up here it says namespace C# classes. So this namespace is basically holding this class. This class is within the namespace. So by using the namespace, I get access to the class. So using C# classes now student, if there's no red squigglies, I'm able to do a student. So now I can do student dot first name is equal to Bob. I'm even going to go so far as to console write line student dot first name. Let's go through the code. So on line 8, I did student dot first name. It even came up from IntelliSense. If you like do the dot and you look at the available options, first name is there. It's got the little wrench next to it. Okay, first name is a property of student. Okay, I defined that in the student class by doing public string first name get set. So now I'm able to set the name of the student to Bob. Okay, now the student's name is Bob. And then when I do a console.write line, I'm able to get that value. So watch what happens when I run my program. Bam, it says Bob. Now you're saying, okay, cool, Jonathan, but what's the point? The point is that now we have a blueprint for student, and I can create multiple students, as many as I need. And not only that, I can set their first name to become something completely different. So console.writeLine student2.firstname. All right, so now when I run my program, the first student, the first instance of student on line 6, his name is Bob. I set his name to Bob on line 8. The second student, I made an instance of the student on line 12. That student's name is John. So they're both students. They both follow the pattern of student. They follow the same blueprint, but the interior is different, right? They both have a first name, but their first names are different. And this reflects reality. In a university, in our app, we have a student roster. Well, everyone's a student, but some students are older than other students. They all have different names. They have different hometowns. So we like to follow a blueprint. You know, we define what a student is, but the problem then becomes, you know, how do we differentiate between them? Well, we create an instance of a student like we do on line 6 and line 12. And then from there, using getters and setters, we can set the value of first name or get the value of first name. Right? And that's what this helps us do. This really cuts down on a lot of typing. Now, you're wondering what this public thing is about. If it's public, then it's available everywhere. Let's switch this to private and you will see what I mean. So I'm going to switch this to private. Now when I go back to program.cs, I've got compilation errors. I got the red squigglies. Why? I'm going to hover over it with my mouse and read the error message. Student.firstname is inaccessible due to its protection level. Well, what does that mean? It's private. Anything private. So this is a property and I made it private. That means first name is only available inside the class. So the class is defined starting on line 10 here with this first squiggly brace and then its partner on line 13. So first name can be used within here, okay, within this area. But outside of the public class student, so in another file, for example, over in program.cs, this does not exist. First name does not exist. If I do even the dot and look at IntelliSense does not show me first name because it is not available. Okay, so you get to choose. If you want your variable to be available to the world, you make it public. If you only want it available within the class, you make it private. There are reasons for why you would want to do that, which we will get into later, okay, but you have that option. So classes also give us a lot of flexibility in the visibility of our properties. So we get to choose, and there's perfectly good reasons to make things public and perfectly good reasons to make things private. Okay, but at least you now understand this access modifier, what public and private do. So let's add some more properties. Public string last name. IntelliSense is absolutely scary. Public int age, it read my mind. Public string, let's do student ID. Okay, because students have an ID. All right, now we've got some properties of a student. Okay, all students have a first name. All students have a last name. All students have an age, and all students have a student ID. All right, so I can go ahead and set these. Student.last name equals Bob Barker. And this is student 2's last name is Wayne. To access these, the first name, last name, and any other property, oh, I forgot the semicolon up here, you're going to use this dot notation. So you can do student.firstname, and then I'm going to do plus, space, plus student.last name, right? It's dot, and then the name of the property, and I'm going to run it. Okay, and there we go, Bob Barker. So that's pretty cool. We are able to create properties for our class. We are able to set their values to what we want, and we're able to get their values when we need it. So already this class is looking like it's way more organized than having like an array of first names, an array of last names, an array of ages. All right, but we have a little bit of a problem. What if our application, there was a requirement that said, hey, our application is used to print student identification cards. Well, we don't want to have a student identification card without a first or last name, because that wouldn't make sense. It would just be a blank identification card. But there's nothing stopping that from happening. Let's say tomorrow someone makes a third student. Okay, student 3 equals new student. Student 3.last name is equal to Johnson. Well, wait a second. Where's his first name? Is anything preventing me? Like, I have the last name, but let's say someone forgets to put his first name. Well, then this student doesn't have a first name, and when they go to print out his student ID card, it's going to be wrong. So there is no constraint, no rule that says the student has to have a first name. So I would like that. I would like to make a rule saying, hey, like, we have students, right? And we have like different properties of a student, but I need to know them to make absolutely sure that they have certain pieces of data filled in. We can do that. We can create what's called a constructor. Here's how you make a constructor. Public student, parentheses, squiggly braces. Let's break this down. All right, first off, the access modifier is public. You could make it private, but most likely it's going to be public. Then we have the name of the class, which is student, and parentheses, and then the squiggly braces. Now, this is called a parameterless constructor, meaning it has no parameters, meaning there's nothing in these parentheses. All right, and you don't have to make a parameterless constructor like this because it comes out the box already. Like, notice how we were able to do line 13 without writing this. Now, I would like to basically define and say, hey, when you make a new student, I need these pieces of information. You got to give it to me. So let's go ahead and put some arguments inside this constructor. So I'm going to do string first name, comma, string last name, comma, int age, string student ID. We'll complete this later, but let's do this part first. All right, so now this constructor is saying, hey, I need 4 pieces of information. The first thing needs to be a string, the second thing also needs to be a string, but the third thing needs to be an integer, and the fourth thing a string. Let's go back to program.cs and you will notice some compilation errors, the red squigglies. Why? Let's hover over it. There is no argument given that corresponds to the required formal parameter first name. In English that means, hey, I need a first name, you didn't give it to me. Also, it's going to need the other stuff too. So notice how it shows the constructor that we made and the order in which we decide things we're going to be in. So now let's give them the information that they desire. Right, I'm going to get rid of lines 15 and 16. I'm also going to get rid of this guy and I'm going to do a little bit of cleanup. Right, so first student's name is Bob, his last name is Barker, his age is 100, and his student ID is some random string. No red squigglies. Alright, so now, get rid of this, I've got my constructor. This is the constructor right here. The constructor is a special method that runs when we instantiate an object. If you don't know when you're instantiating something, the biggest clue is you're using the new keyword, right? You're making a new student. Go to the blueprint for student and create me a new one. Well, the constructor states that I have to give it a string, then an integer, then a string. Now, biggest point of confusion among beginners and biggest mistake. I named these first name, last name, age, and student ID. I didn't have to. They don't mean anything to the computer. The computer doesn't actually know what a student is. It doesn't know that students have a first name. That has meaning for us as the programmer, as the humans. For the computer, it's just a string. It just basically holds the value. It has no idea what that means in the real world. Also, we actually haven't set first name for this student. So when we create a new student, the first name will be blank, and we haven't actually set it yet. I'll prove that to you. So here, I'm going to pose a student.firstName and student.lastName. Now here we give it Bob Barker, so the screen should say Bob Barker, right? The screen says absolutely nothing. Okay, it's blank. There's nothing here. All right, that is because we put the value in the constructor, but we haven't actually set the first name for the student, this instance of student, nor the last name. How do we do that? Well, we do it inside the constructor. I'm going to use a this keyword. This.firstName equals first name. This is self-referencing. Okay, this references the student itself, this instance of the student. Okay, so when I create a student like this, the this keyword refers back to the student variable. If I create another student, the this keyword will refer to that student as opposed to the first one. It's self-referencing. That's the best way to kind of think about it. All right, so I'm going to do that for the rest of them. This.lastName equals last name. This.age equals age. This.student ID equals student ID. Now, I did use IntelliSense to type that out pretty fast, so do take your time. All right, but now, if I run my program, it should say Bob Barker. And it does. All right, why? This string here is Bob, this string is Barker, all right, first name, last name, and I said this.firstName is equal to first name that's coming in. This.lastName equals the last name that's coming in. So these values are provided for by the outside world. They come into the constructor, and I set the instance of student. I make those properties of value equal to what's coming in. Biggest beginner mistake is thinking that like this order makes some sense to the computer or that these names have special meaning to the computer. They do not. The computer does not know that. I could name this aardvark. This is just a variable. I could name this aardvark and put this.firstName equals aardvark. Now, that's nonsensical and a little bit silly, but my program will work just the same way it did before. So if I run it, it's still going to say Bob Barker. Okay, there's no change in the functionality. This is just a variable like any other variable. It does not match them up based on name. It does not know that this is the first name. The computer does not do those things. Okay, it just does not. So that is one of the biggest things that people get wrong with the constructor. So I can name this whatever. People name it what it is because this makes more sense. So when I'm working on my program, I understand I'm talking about the student's first name or last name or age. This naming convention makes sense and allows me to work with other programmers in an efficient manner. Alright, so we've got the constructor and we've got the properties with their getters and setters. And then last thing we're going to do is make methods for our class. And we've been using methods for classes. So for example, I had string name equals Bob. We had name.toUpper. Right, we had to upper, to lower, right, index of those string methods, right? These are methods related to strings. If you're ever curious about them, you can always right-click and go to definition, And you can look at the matrix code for C#. Okay, you can look at a bunch of the different method signatures that they have. Okay, if you're ever curious, right? But to upper was a method. It was a pre-built piece of functionality that we used to turn a string all uppercase, which was great. Now we can make our own methods. Like there's pre-built ones that other people coded for us, but if we want to make our own, we are perfectly capable of doing that. So how do we make them? The first thing is an access modifier. We're going to make our method public. Then we're going to do what does it return. Now you're probably thinking, what do you mean, what does it return? We've been using method returns when we did the guessing game with random. So let's make random equals new random, int random number equals random.next 1, comma 11. Here we go. Remember this? This next is a method. Okay, it's part of the random class. This is a class. Okay, class system.random. So if you want to click on it, you can even look at it. Here's public class random. Like I've just pulled back the curtain and showed you the matrix. Like this is an actual class that someone wrote a long time ago. It has a method called next. Next returns an integer. What does that mean by return? I'm going to go to definition, and you can see it in signature. It says int here. That means when the next method runs, after it's finished running, it will give you back or spit out an integer. Not a string, not a double, not a float, an integer, specifically an integer. So when we do random.next, it spits out a number which we save in this variable random number. Okay, random number holds the value that is returned from the next method here. So you got to think of methods as taking things in and putting things out. It takes in these two arguments, 1 and 11, and puts out an integer, which we save in this variable. So that's what methods do. They take things in and they spit them out. Let's make our own method. So we said public, and then we're going to do a self-introduction method. So we want the student to introduce themselves. All right, that sounds like a string, so this is going to return a string. And then we're going to call it self-introduction. And we're going to put parentheses and then curly braces, and then bam, we've got a basic method. Now it still's red, so it's basically the reason it's red is not all code paths return a value. If you have like string, integer, double, if your return is a type, then you have to return something. So I'm going to show you how to do that. We're going to use the return keyword, and we're going to do return. I'm going to use some string interpolation. Hello, my name is this.first name, this.last name. Return. Hello, my name is this.first name, this.last name. It's a string. See how I put the quotation marks that it's a string, and that red went away. Well, we said that this method gives back a string. It spits out a string. The return keyword, therefore, is necessary. We must have a return keyword and then a string in order for the code to compile. Okay, if I don't have this, like let's say I comment this out, this is not going to compile. Why? Because there's no return. Not all code paths return a value. So that is your cue to say, oh wait, I forgot to put my return here. Once it's in there and it's the correct thing, therefore it's fine. And also it cannot be something other than a string. I can't return 10, for example. 10 is not a string, 10 is an integer. In the method signature, I said that it's a string. All right, so let's put this together. I'm going to have it return this, and let's go ahead and use it. So now I'm going to get rid of this stuff. I'm going to do console, let's do string greeting equals student dot, and then you can go through here and you can look. There should be a method called self-introduction. We're going to put parentheses, and what this parentheses means is, hey, I want you to perform this code. So when the computer gets to here, it'll be like, oh, there's a method called self-introduction that exists in the student class. I'll go to the student class and go run it. So it'll come to line 24 in student.cs. It will come to line 26, and then it will perform this code. All right, so I have greeting, which it will run the self-introduction method and return a string, which will get stored inside this greeting variable. Then I'm going to go ahead and console.writeLine greeting. I'm going to comment this out so we can see what exactly is happening. Hello, my name is Bob Barker. Awesome. So now we have a student that can introduce themselves. And the introduction will change based on the student, which is really cool. So I have another student. So I say, like, I don't know, his name is Michael Myers. 200 and then random stuff for his student ID. I can also do string greeting 2 equals student 2 dot self introduction parentheses and console dot write line greeting 2. And now they'll both be able to introduce themselves, but they'll be different. The first student will introduce himself as Bob Barker, and the second will introduce himself as Michael Myers. So this allows different students to have the same functionality. Students can introduce themselves. All students can introduce themselves. Now, what they exactly will say will depend on the student, but all students are capable of introducing themselves, and the self-introduction looks like this. All right, now, there's more you can do with methods. You also can take in parameters, okay, arguments. Let's say I wanted the student to introduce themselves multiple times. Let's say I didn't want to return it as a string. Let's just say I wanted to write it to the console. All right, so I'm going to kind of clean this up a little bit. I'm going to get rid of these and get rid of these and just have my 2 students. Now, let's say I want to just console.write line this. I don't want to return it. If your method doesn't return anything, you can use void. Okay, void means it doesn't return anything. If you do void, you cannot have the return keyword. So we're going to get rid of the return keyword, and we're just going to do console.writeLine, and we're going to put this inside of that. Now, let's say I want the student to introduce themselves like 5 times or 10 times. I'm going to have an argument here, a parameter. I'm going to do int number of times. And again, this is potato. I could call this whatever I want. All right, now when we run the self-introduction method, it takes in an integer but doesn't return anything. Okay, that's what void means. It doesn't return anything. So I can do student.self-introduction, but now notice that it has a compilation error. I have to supply an integer. That's part of the method signature. This part of the method is called the method signature. Okay, it includes what it returns, the name of the method, and any arguments it takes in. So I have to provide an integer. It requires it. I don't have an option. So let's say I put like 3. Cool. Hunky dory. The compiler is fine. So then I can use a for loop for int I equals 0. And IntelliSense is very scary. It knew I wanted to loop based on the number of times. Okay. And say now I can have the person introduce themselves some number of times, and I can adjust that. Let's say I want it to be 3. Bam. Hello, my name is Bob Barker 3 times. I can adjust this and make it, I don't know, 10 times. So now I can change the way my program behaves by adjusting the value of the arguments that come into the method. Now, methods can have any number of arguments. You could have 100 of them. I don't recommend that. It'll be very hard to type it all out, but you could have it. And they can be strings or booleans or lists or dictionaries or whatever you want. Now, last thing we're going to talk about is this public thing. You also could make a method private. Just like with properties, private methods are only available inside the class. So now if I go back to program.cs, you'll notice that there is a compilation error. Why? Because self-introduction is a private method. Program.cs is outside the student class, and therefore self-introduction is not available. If I do student dot, notice how IntelliSense does not have self-introduction anywhere because it is private. It's the exact same idea as with making properties private. So if I want it available outside this class, I have to make it public. There are other access modifiers, but for beginners, public and private are more than enough. There are a lot of good reasons to make methods public or private. Okay, it depends on the situation. For right now, just know what they mean. Okay, and as you get better at coding, you can apply them when you want to. But now we see the power of classes. Classes have properties. They have constructors. They have methods. They can basically, they're like data combined with doing stuff. All right, and they're very, very powerful, and they're the bedrock of all pretty much most software. Again, There are some pieces of software that are not based on object-oriented programming, and that's perfectly fine. Like there's functional programming, cool. Okay, but a lot of software out there is based on OOP, all right? And so being able to build your own class, create a constructor, create properties, create the methods, okay, properly, it goes a long way into mastering C#. Hi there, and thanks for watching. If you like the content of this video, please like and subscribe.